new release officially came out July 1st. Mastercam does have a new schedule. Every July 1st is when it'll get released, so you don't have to guess on it anymore. I'm just going to go through a quick itinerary, kind of what we're going to do. If you don't know me, I'm Justin Patterson. I'm the local application engineer here in Wichita. We also have Kyle Mills here. You guys might deal with him through some tickets. He's based out of the St. Louis office, so we both kind of have the same role. To start with, I'm going to give four or five, kind of what's new with Mastercam 2026. We're not going to go over all what's new. There's a lot of it, and I'm going to show you where you can get these resources to check that stuff out. And then I'm going to give a couple little tips and tricks. I'm going to do 3D lathe tool because I know a lot of people struggle with that, and it's just something we kind of talk about. And then a little bit of unified stuff. I know that some of you guys watched my unified webinar a while back and like that, so I'm going to do a little bit on that. We're going to take a quick little break, and then Kyle's going to get up and kind of do the same thing. The rest of the 26, some tips and tricks. He's going to go over cam assist and stuff like that. Then we got Christian here from SECO Tools. He's going to get up and give a little presentation. Yeah, we got Mark over here from Verisurf. He's going to be over here in the corner, so if you want to go check him out and ask questions about Verisurf, he's the guy to ask. We also have Matt Smith here from Sandvik, so if you have any concerns or anything, or just want to talk Sandvik and Mastercam, that's your guy right there. So, yeah, we'll go ahead and get started. Again, if you have any questions, let me know. Kyle will come around with a microphone. I'm going to keep most of the Q&A to the end, but if it's in relation to something like a slide I'm on or something I'm doing, ask it. You know how most of you guys taking training from me. You know how I work. But we'll go ahead and get started. Let me share my screen here. Okay, entire screen. Okay. I don't need picture in picture. I don't know how to get rid of that. Put that there. Okay. So, oh, might help if I would have started the presentation. That usually helps every once in a while. Okay. And also, I like the little pointer thing where you guys can see the pointer. That usually helps too. There we go. Okay. So let's start talking here. Okay. So starting with Mastercam 2026, this is one thing that's going to be a hot topic. I'm going to go ahead and say that right now. I'm going to do one, and then Kyle gets to get talked about the other one. But they redesigned the planes manager. Okay, I am pretty excited about it. There are some things that I'm just going to tell you is going to get some getting used to. Okay, so just be prepared for that. So I'm not going to spend a lot of time on these slides. I'd rather just show you, but just kind of the overview. We have the ability to now put groups with planes, which I think is really nice. So now, the minute you open a file, you have your system planes, top, front, back, left, bottom, ISO, reverse ISO, so on and so forth. Those automatically come into a system plane folder. So it kind of condenses everything down. Those of you guys, Mitchell and Matt, running Milturn a lot, this is going to be your best friend in my opinion, because we know Milturn produces a bunch of planes. We can now start grouping all that stuff together. So that's a pretty nice thing, I think. We do kind of have a new interface on what's the WCS, what's the construction plane, so on and so forth. And we'll go over this. This to me is where it's getting pretty powerful, is the search function. You're going to start seeing themes of this when Kyle does his presentation, what they're kind of aiming for. We have a little bit more properties, so on and so forth. So let's actually just jump into that real quick. Okay. So if I go grab a new machine, actually, I take that back. I'm going to go grab, we have these little things right here. So I'll go planes. Okay, we'll go grab the planes manager. Okay, so here's our file, and here's our new planes manager right here. So by default, this properties manager is actually turned off. Can everybody see that? Okay, yeah, it looks like it. Might go one size up on font. Okay, one thing straight out of the bat that's kind of neat, you don't have the columns you have to sort, when you go in there, you have to make the C, the T, make them just the right size. That no longer exists. It's proportionate to where you stretch it onto your screen. I do like that. I mean, I really do. It does struggle like when you condense it a lot like this, but that's just the way it is, okay? So looking at this, you can see we have a new way to define what's our WCS, what's our construction plane, what's our tool plane. It's, to me, I like this. It's a little more visual. You can quickly kind of glance at it and kind of see. We still have the contrast rows. That function is still available. But you can kind of see, you still have the ability of locking a tool plane. Section view is a little more visual as well, to where you can actually see when that plane has been section viewed or not. You still have to turn it on here, so on and so forth. And then each plane, you have the properties for this plane, or what we want to do with this plane. This was kind of driven through the right click before, but now we just have the 3 dots. And actually the right click still works as well, just showing you that. But what's really nice about this is we have, first of all, we have a search function. So if I want to show me all the planes that have rib in the title, it'll automatically show me just the ribs planes, okay? So I can then go in there and I can grab all of those ribs planes and I can right click and say, let's add a group. So now I've created a group that I can go in here and rename, and I'm going to call it ribs. Okay, so when I clear my search, I now have a group for that. So what makes this really nice is I can condense that. So you're starting to see how we're going to clean up all these planes and keep things a lot more organized. Same thing with like standoffs. I come here and grab these standoffs, right click. My right click will work. Group. Okay, rename. Standoffs. Okay. So the other advantage with this is you have the ability of moving stuff around real easy. You struggled with this before, moving planes to the right order is what you wanted. Now it's just simply drag and drop. I want ribs up there. So I can say, I want my op1 planes, my op2 planes, whatever order I want. I can just move them around in whatever order. They're trying to break the old way of doing things where it had to be in the order they were created or using their certain sort methods to where you can really have a lot more control over this. So one thing I do want to say is if you look, and if I go to drag this, it's going to be very subtle to see, but you see how that black bar is? If I come up here, you're going to watch it indent. See that? See that little indent right there? That's just determining, do I want it right behind standoffs or do I want to put it in the group of standoffs? So see if I come in here, get the little indent, I'm going to put it in that group. So you got to be kind of patient and mind that when you're doing that. But I think it's a pretty nice little feature that's going to help a lot of people out. Like I said, by default, properties is off. They did leave that in the plane side of things. And what I really like about this is it's so much more visual. You see this little icon here? This says that the work offset's set to automatic, which most people use automatic. Okay, we want to go run G54. So I'm just going to use this one as an example. I go in here, I say manual. I'm sorry, 55. So I go in here and I'm going to set the number 1. And now it's just more visual. You see how we kind of see here on the screen, it says 1. It stands out a lot more in my opinion. I do really like that feature. You also, this is the new look for show, no show. I'm going to do a Kyle trick here. Sorry, Kyle, I'm stealing your thunder. But right there, it's kind of hard to see. I'm not even going to lie. Sometimes to see, is it on or off? So if you look, you get a little eye open versus a little eye closed. So you're going to have to really start playing with your font size in these windows, but pretty nice little feature. Also, we have sort functions, and this is where I think they're really going with this, is we can sort by name, work offset, all of this stuff. You're seeing what I'm looking at. These are all the things we can sort, and we can also filter. So we're starting to go more like kind of like an office theme, you know, like, hey, I only want to show these planes or this, so we can sort them and all that stuff. So I do think this is a really nice addition to be a lot more organized. They're going for the organized theme is what we're trying to go for here, okay? So any questions on planes real quick? I know it's new. It's going to take some getting used to. I ain't going to lie, but it's going to be a good thing. So, okay. I think it starts at the beginning every time, doesn't it? Yeah. I shouldn't be able to go. Okay. So this one's nothing too big, too fast, or takes too long on this. Is actually, if you kind of look, they changed when we go into here. Okay. So before, when we needed to go define our stock, we needed to go define anything like that, we'd have to go to the properties in that tab. Now they just broken everything out to where now we don't have to go into a folder to go to a tab or go to a section, if I can speak English today. You just can jump into the exact portion that you want. It's still the same interface. It's just they brought everything out to the front end. So I do like that. It's a lot cleaner. It's a lot faster to switch between what we need. Instead of, oh, I needed to go to my master model. Oh, I click stock and go to master model, so on and so forth. So But while I'm on it, this is a pretty nice little function they came out with, is now everything's more visual on the graphic screen. It tells me what my C-plane is, what my WCS is, so on and so forth. So it's really nice. I don't no longer have to look down here. Let's face it, no one really looks down there. People do, but I'm not one of them. Where here, it's just a quick little visual. I can look over there, see what my construction plane is, see what my WCS is, and I can also change it from here. And see, it still retains the same folders that we did earlier in this view. So you can kind of clean up a lot more. Plus, it gives you the ability to create planes from this. So you don't even need to go to the planes tab anymore. So that's kind of what they're trying to do. They just want to streamline all this stuff. Okay. I think it's in the next slide, but I'm just going to go and say it right now. I don't know how much this means to a lot of you, but this is not a really good example. Let me just go open one that's a good example of it. Say we go open one of these postability posts down here. Actually, Mastercam. I'm just going to grab any one of them. Okay. It's still not really showing it, but have you ever seen it? I should have probably done this beforehand, but I forgot. Where it doesn't really show the complete path. You'd never know what's at the end of it. It only shows what's at the beginning of it. Now, as you can see, they kind of condensed it down to where we're seeing what the actual post and the machine definition is. They're not starting from the beginning, they're starting from the end. So something a little simple like that I think is pretty nice. But you have always been able to hover, and it will tell you that way as well. Okay. Let's see. Again, I wish this thing, I'm sure there's a way. I don't use PowerPoint very much, shows it. Okay. The tool manager improvement. This is actually kind of a nice little function here. I think this is really good. If those of you are used to creating 3D lathe tools, you're going to be very familiar with what's going on right here. I'm probably just going to go ahead. I'd rather just show you, okay? I'm using that more as a guide. Let's jump in here, and I'm going to go just create a new file, and I'm going to go grab a brand new machine. Just default. We're going to go in here to the tool manager, and I'm going to go create myself a tool. You're going to notice it's a brand new interface, and I think this is a lot cleaner. It's a lot more intuitive, in my opinion. So here we can name it. Okay, what's the name of our tool? What's the description? And then we still have our EDP number, our manufacturing code down here. All the boxes that were in the previous one are here. They're just kind of in a different location. But I think the flow works a lot better now. So we choose our type, so on and so forth. We give it all this information. I'm just going to start with this, and then we're going to bring a tool in. So I'm going to do tool number 1, flat end mill. It's this. What's my helix angle? Doesn't really matter. Then I jump over here to the actual geometry tab. Okay. So here's where I can define it. What's neat is it's kind of a little better visual graphics over here of what we're doing. So it's a 1/2 inch, right? We're going to do, let's say it's 3.5 inch overall, 1.25 length to cut. So on and so forth. And then you can come in here and set your feeds and speeds, your rough step over for finish and roughing. And then you also have your coolant tab. Okay. But let's actually merge in a tool. I'm going to do a lollipop tool. Okay. I'm going to go do that. And you come in here and name it. I don't remember what the diameter is. Let's just say it's a 1/2 inch. Don't judge my spelling if I'm not very good at it. My wife makes fun of me because way I spell, but I made it this far in my career by spelling like an idiot. I think I'm going to be just fine. So one thing I do want to bring up that I like, this is a little trick that I like to do. If you're creating a tool, most of you guys run standard tool list, right? Or standard tools in the machine. Well, when you create a tool, you might not know where that's going to be going in the carousel. Set it as a 0. That's a good little rule of thumb. That way you're alerting yourself that this tool has not been assigned yet. When it goes to run on the machine, it's going to error out and not allow it to process that tool. So now you're not running what I think is a 1/2 inch lollipop tool. We're using a 2-inch face mill instead. So that's just one thing I like to throw out there. But let's jump over here. Okay, so same thing like before. We can bring in from a level, so on and so forth. I'm just going to go grab a step file that I created earlier. It's right here. Just called it tool. Okay. And what we're going to see here is we're going to see this come in like this. So if you haven't been aware, when you bring in a solid tool, there's 2 types. There's the, let me just do it like this. There's, call it the yellow, the Mastercam tool, and then there's the imported solid, which is called the parametric solid. The Mastercam, or the anti-collision, that's what's actually generating the toolpath. Okay, just so you know, that's what's going to generate the toolpath. The parametric model is what's going to show up in our verify, and it actually does check against collision with that as well. So what they're doing here, this is what I think is the real neat function, is you see how it didn't come in very well. And see, I can just flip between them. I can do them both as wireframe. okay? But it didn't bring it in quite how I want. You can actually pick off the model now instead of having to type all this stuff in. So like right there, what's the diameter? Well, I can actually go pick the diameter. Now that I should have cleaned this tool up. You still have your right click. What's the diameter of an arc? These are not very good. Apparently, I did not clean this model up very well. Let's just reopen it. Okay. But you can go pick from the model if it's a clean model. And here's an example that I want to use is like the overall length looks good, but what are we doing? We need to put this taper in. Okay. First of all, our shank size right here. And if I click on it, it'll actually show me what it's after. So there's the shank diameter, there's the shoulder diameter. So let's start with the shoulder diameter. So I can right click. I'm going to say the distance between 2 points. I'm just going to pick this, go from here to here, and there you go. So it's nice because how many times you've got the little blank screen with the red X and it just drives you crazy. Like, what do you need? You know, this solves that problem. It'll actually warn you. It'll tell you if you do something wrong by highlighting the box red, if it can't achieve that. So like, let's say if I do that, see, it popped up, say, hey, I can't make this happen. And it's telling you what the problem is, where before it never did. It just lets you guess. So I do like that feature, and having the ability of coming in here and picking off the actual model is very nice. Okay, so then the shank diameter, I'm just going to say that's 250 for now. But there's that. What is my true shank diameter? I don't know. Distance from 2 points. I go right here, and I pick from here to here. There you go. So see, we're just building everything off of the actual solid. Okay, I have a taper here. Well, what's my taper? Well, I can go measure it. What taper do I have right here? There it is, but my taper length is wrong. So it's going to be, I can do the distance between 2 points on this as well. I'm going to go from here, or O for origin, and go to the start of your taper, which is right there. So let me make sure I'm doing the right one, though. Shaded wireframe. Okay, so it's actually up there. I picked the wrong one. So right there, distance between 2 points, O for origin, and go pick where you want the taper to start at. No, I did do the wrong one. Here, O for origin, and I want to start right here is where I want my taper to start, and then I can come in here and pick my taper. That's my actual taper. And I am backwards. This always confuses me. And it doesn't help when I'm trying to do this in real life here. Oh, it's because right here, I know right here, my cutting length and shoulder length. See this? We come in here and we have a shank diameter, this, and then this is the one I was doing wrong. I'm picking the wrong one. So come in here, distance between 2 points, origin, and go pick right there. There we go. But see, at least it's giving you more of a visual of what it's after. Don't do what I do. You know, I've told you guys that 1,000 times, but there, now I've got an exact representation of the tool that got brought in. So I think it's a little cleaner on how we can create tools. You can also make it a little more translucent, you know, if we want to see the wireframe behind it, so on and so forth. So same thing, we get all this information here. We can hit save, and there it is. Okay. One thing that is neat is they did kind of, I mean, it is very similar to the way it was, but the tool assembly is pretty nice. You can come in here and we can name our tool assembly. We can delete it. This is, like I said, this has been here that just it's very little changed. I can create my tool assembly through here instead of having to do it through the holders tab in the actual operation itself. And see, I can still import from a library. So I go grab that one. And this does give you the ability to change your stick out just right there, okay? Just by moving that around, okay? But yeah, other than that, that's kind of the new tool designer. Anybody got any questions with that one? I think it's going to be a nice little addition. Okay. Green shank that. All right. I'm just going to get to here. Okay, so this, I'm not really going to do a full demo on this one. Is there a way to start from here, Kyle? Do you know? Let me go to, sorry, technical support, right? There it is. Start from current slide. There you go. So you just got to be smarter than me, which isn't hard. There's a lot of people in here that's going to like this. Millturn now has the legacy style toolpaths available. So you get the surface rough, you get the parallel flow line. I mean, everybody's been asking for flow line. I was always told the reason why was because that older interface, that legacy interface, they couldn't implement into Millturn yet. Now all those are available inside of Millturn. So I don't really need to do a demo on that. It's just those of you guys that use Millturn will know, especially if you love Flowline, which, yeah, it is now available for you to use. Okay, so it's just a little demo there. Okay, so this is kind of neat. This is what's called taper helix entry. This is available on your dynamic style toolpaths, okay? Let me open that demo, okay? Whoop. Tapered helix entry right here. Here we go. This is a metric one, which is fine. What they're trying to show here is when we go in, and here's another little trick if you didn't know. If you're running 25 and newer, this came out, I think in 25, maybe 24. I can never remember anymore. As long as you have a stock model in front of your toolpath, if you just select them both together and go into verify, it automatically will start the verify stock from that stock model. You don't have to pick it anymore. Like I said, that's been, I think, out since 25 is when that original, or 24. But if we come in here, let's do a section view. Okay, I'm gonna do, I think it's gonna be an XY clipping. Yep. And I'm just gonna drag it. Let me get this started. Get the tool in there so I can see where we're at. Okay. Right there, and I'm gonna turn my fixture off. And my part, I don't need my part. Okay, so if you look here, so what's gonna happen, traditionally, the way this works, we left. Oh, my computer's screaming now. Is it's going to go full depth before we start bringing our motion out. Now, the problem with this is you have full flute length chips trying to evacuate this small little pocket. Probably not a super big problem, but it can be a problem, right? So that's one of the things they kind of came up with is they introduced into our high-speed toolpaths the ability, it's right here in entry motion, to have tapered helixes. Okay, so this is an automatic calculated helix. So all I'm doing is checking that box. Okay, I'm a green check. Regen. Let's jump back into here. Let's go back into here. And you're going to see the difference now. So now when we come in, oh, I got to move my computer does not like me. Let's get this going down here a little bit more. Come on. Oh, it is angry. So by the way, another one, if you didn't know, your plus and minus keys on your keyboard will speed and slow down any of your verify. Same thing with simulation, does the same thing. Okay. But if I look here, it's going to start, it'll eventually get, there it goes. Okay. If you actually look, it creates a little tapered helix in there. And this is all automatic. You don't have to figure in this. It's all based off the geometry of your tool. So now when it gets down there to the bottom, it's starting to take a thinner chip, finally getting up to a bigger chip, which I know Christian here with SECO could probably say how important that is. I'll let you bring that up at your turn, but yeah. But yeah, it is important. I mean, especially on hard metals, like just off 1,000 foot above, what's the advantage in something like that? Not to put you on the spot, like putting you on the spot. Yep.
Oh, yeah. Okay, test this. So yeah, for your hard materials, it's all short chipping. So that's not as difficult, but in your long chipping materials, that taper is going to really reduce the chip length that, especially when you're down in a cavity like that.
Yep.
Yeah.
And plus it helps get those chips out of there. It's just a win-win altogether. So it's something super simple, I understand, but to me, those are those little advancements we need to start making as a CAM package to make this cut more efficient. So let me show you what the math is. This is just a little diagram, what it's going to do. But I think it comes out to 85% and 25% of your tool. If you do the math, my math's horrible. 1/2 inch tool, it's going to be a 475 at the top, and then I think it's like I forgot what the bottom is, but it's 25% the diameter of your tool. So that's an automatic helix. I don't think there's a way to actually change that formula. It's all built into that calculation, but I don't really see a need to. Okay, so yeah, I think that's what. No, I had process hole. That's right. Okay, so let's get down here. Let's go from slide. Okay. Process holes, or not process hole, but solid hole functionality. This is, those of you that use SolidWorks know that SolidWorks great at creating holes, like having templates and all that stuff. We've had this for a while, but I think they kind of stepped the game up just a little bit in this, and it's how they create solid holes now. So let's go open up that real quick. Go here. Solid hole functionality. Okay. So we've got this little cover right here. Have all the points. Now that's the one thing you need to understand when you're doing solid hole creation. You can use auto cursor points. What that means is you can just pick somewhere in the model and it'll put a hole there. But your best bet is just to go put points there. It's just a little cleaner interface in my opinion. Okay. So if I go in here to solids, I can jump in here to holes right there. Okay. So here's where we go in here and tell it what plane we're on. And you can do a name plane. You can do a graphics plane by picking an actual face. Okay. Then we can come in here and pick our position. So like I said, I can use auto cursor functions or I can add positions. And here I can actually just window all those points in. Super simple. And I hit enter, which brings me to my next interface. Okay. So you can see this has changed a little bit. One thing straight out of the bat I want you to notice is they give you a live graphical screen update of the hole and the whole geometry. So this makes it a lot nicer when you're going to create this stuff, unlike before. You still have your libraries. Okay, we can change it to ISO, JIS, whatever you want. Come in here and find these different templates, right? Whatever template I want to run. And then if you didn't know, you can break it down farther. Hey, I want to make it for a dowel pin, or I want to make it, you know, so like if I come in here and do a threaded hole, my computer, come on, what I'm unified course, what thread am I working with? I'm going to do a 3/8/16. See, it does all, it populates all this information for me. It gives me nice little visuals, okay? So that's pretty much the main thing with this is it's just giving you more visualization, but there's one added step to it. You can create user libraries, okay? So I just kind of did this just playing around. I just created this 3/8 shoulder bolt, okay? I told it that there's a straight pitch to it. It's just a custom thread. There's a straight with a thread with a taper at the end. So those of you guys that are finding yourself putting the same bolt holes in all the time, my ICT build guys might like that, right? So they're doing these same fasteners or these, whatever you're doing, you can create these templates to where I'm doing this whole structure every single time. This is going to turn into, I think, when's the webinar for process hole, Erica? Is it next month, August? August 25th, I'm going to do a webinar on process hole, which really utilizes this to its full advantage. So I'm going to leave you waiting on that one. But this is where all this starts, is creating this good in your model. If you were like me, it was just wireframe circle, extrude down. That's what I did forever, just because that's what we know. Start getting used to this, because with way things are going, giving it this information is only going to make Mastercam smarter. It's going to do this stuff for you. So that's where I think we're going. And this is, again, my opinion. I keep hitting this thing. This is my opinion. I just think that we're starting to work ourselves towards that, to where it's going to help you create less work for you. This isn't a lot of work to just go through and do stuff like this, but I do think this is a really cool function. You do have the ability of changing the color on the threaded versus non-threaded side. I did bring up to them when this was demoed to us that I would love to be able to even do different colors, because the way I work is I go in, my dowel pins are always red. If it's a reamed hole, it's always red. A clearance bolt's always orange, and a threaded hole is always yellow. I want to see if they're going to hopefully someday add that functionality to where I can just look at the model. Oh, that's a red hole. That's a reamed hole right there. So that's something we're hoping to see, but we're getting there. Okay. No, yeah, just assigning color. Just because I know when I do a dowel pin hole, I want it to be red. That way I can visually look on a fixture grid plate and I see my red holes. There's all my dowel pin holes. Or if it's yellow, I know it's a tapped hole, threaded of some sort, you know, and then orange will always be my clearance holes. That's just, and I brought that up to them during Mastercam, and, you know, they are aware of something like that. So yeah, and just, you know, Matt's a good example of this. You know, Matt reaches out to us all the time when he comes up with ideas with mill turn. Don't be afraid to reach out to us. We'll send that up to Mastercam. You know, we want you, Jesse, go ahead. Okay, hold on. You're talking too quiet for me. Yeah.
All right. So you know the toolpath section at the top?
Uh-huh. Let's go. Let me close my hole out. If Mastercam allow me, go
The
here.
way it groups it when you do a drop down for, say, lathe toolpath, drop down one of those menus.
Oh, any of these like this?
Yeah. Okay, that one doesn't have a group. Do you have a lathe one?
You want a lathe? Let me go grab a lathe machine. Hold on.
Sorry.
Okay, so here.
Yeah. Can you make it to where the bar that says canned or manual, to where you could drag that bar and move that group to the top, like reorganize the groups in whatever order you want? Because quite frankly, where I'm at now, they use a ton of canned. And so if those were at the top,
Yeah.
I wouldn't have to tab down every time.
Or just hey, take it another way, almost not only that, but make custom groups. You know, have a group up there to where I could drag and say, I've used this, this, and this the most, where I don't have to hit the down arrow. It's just right there.
Okay.
Yeah. I mean, would that kind of go down what you're saying?
Make another, that would do it too. And then just put those 4 in that group.
Yeah. Yeah. So that Kyle is correct. If you just sit here, you can scroll. Well, no, hold on. I thought yeah. This scroll. Yeah, that scroll, not the wheel. Yeah, you can just hit, but I mean, I see what Jesse's saying. I mean, if I go to a hole size, granted, if you use a drill, it's going to be there because I just used it. But it would be nice if, hey, I'm always doing dynamic, I'm always doing contour, and I'm always doing drill. Let's just keep those there at the very front. So
right.
Matt is writing that down. So like I said, Matt's kind of the guy that can kind of relay a lot of this information. So yeah, that's the stuff I want to hear. You guys are the ones using this every day. We want to know the function. And I'm just going to say this. I'm not quite done yet, but one thing I want to preach to you guys is ask for help. If there's something you're fighting, ask us. Because, you know, I've learned from you guys how you do things. That's how I've sharpened myself. Same thing needs to come from you. If there's something you're like, man, this just takes me forever to do, just reach out to support. Say, hey, is there a better way to do this? You know, that's what we're here to help with. And if we don't know, we send it up to Mastercam. So that's our whole goal. We want to make this more streamlined for you guys. Okay. Any other questions with that? I think that was it. Yep. Okay. That was pretty much the whole function thing. I'm going to jump into a quick little unify. Well, let's do the 3D tool first. How many of you guys do lathe stuff? How many of you struggle with 3D tools? Okay. It's a pain in the you know what, right? But it's really not. Once you understand how it works, it's pretty easy. It's actually very simple. So I even gave you one that was a little more difficult, as in it's this tool right here. Okay. It's a face grooving tool that actually has a couple different features to it. I have the stick itself, the body, and the insert. Okay, one way you can do this, technically you could Boolean all that together and just make it a holder and an insert. That's really the easiest way to do it because it's not like I'm gonna switch that model out with something different. I just create a new tool. But if you wanna have traceability of EDP numbers and part numbers and stuff in our 3D tool, we don't wanna do that. So I'm gonna kind of show you how to do this. Okay. So I am just so I get this out of here because I've got it saved as a step file. Okay. Remember, you just have to have it saved as a step file. And the other thing, assemble it outside of the tool tool designer. Assemble it outside of it. That's the easiest way, and save it as one step file. That's the key. Okay. So if we jump in here, I'm going to go grab a lathe. Okay. My lathe tool manager. All I do is I right click and I say create 3D tool. Okay. Actually, I forgot I did create a little, because Kyle brought this up to me about showing the collision. So I did make one last night. So let me open that up. Kyle, if it wasn't for Kyle, I'd forget too much stuff. Here. 3D tool, face groove. Let's open that up. Okay. So it's just showing, you know, why a 3D tool is important. We're just going to do this simple. Don't you guys all wish you just did simple like parts like that all the time? Life would be a lot easier. You get paid a lot more, right? Create 3D tool. Okay, so here you go in. This is where you're going to give it your name. This is all pretty plain and simple. We're going to give it the name of our tool. And this is how it's going to show up for you when you go pick it, okay? Kyle is going to give a little demo of X+, which what's really cool about X+ is it'll pull whatever information you want, tool name, description, EDP, everything, it'll pull it up. But I tell everybody this name here is what you understand, okay? Or I know like Jesse's working with all his tools now. They've got a very specific way they want their tools named. So this is the way you guys want to do it, okay? So what type of tool is it? Well, it's a face grooving tool. What's your tool number? Does it require a tool locator? This is for mill turn. I get asked that question a lot. This is for mill turn. Something like this would require a tool locator because it's a stick. So it's going to need the locator mounted into the turret in mill turn. If you're running a capto, make sure that's unchecked. Because if you say it needs a tool holder, it's going to take your capto and mount it into something, and it's not going to be right. Okay, so very important you do that. So go to the next. This is our tool assembly. All I got to do is I got to right click. I'm going to define a component. And the first one, these kind of make no, I mean, not that they don't make no sense. They just make no sense to me. It's holder, extension, adapter. Okay, the way I look at it, a holder is always going to be what's holding the insert. That's the way you have to think about it. Where I think like the stick is your holder, that's actually considered an adapter in this instance here, okay? So I'm always going to start with what's holding the insert. That's just the way I like to do things. Okay, so I've got my holder. Again, give it the name. I don't have this one up, but you guys have all seen, those who have taken my training know, when you go to the EDP, like let's say we go to SECO's website, all the information is there, their name. Go ahead and copy all that. And then when you hit Windows V, it puts everything into a list and you can grab each one at a time. So I'm not having to keep flipping back between the SECO website and Mastercam. I just copy everything I want. I go to here and I hit Windows V and it'll bring up a clipboard and I can pick which one I want to paste in there. I just like to throw that one out there because a lot of people don't. That's a Windows function. Okay, well, what model are we going to use? Well, since I'm going to open the step, I'm going to go here to select model. Okay, I'm just going to grab this one right here. Okay, and it's going to bring in my model, completed model, and pick what's the actual holder considered. Well, it's this right here, hit in selection. Let me rewind real quick. What I want you guys, because Casey, we were just talking about this. I think it was me and you, Casey, I can't remember, but how do you bring your file size down on Lathe 3D tools? Well, the number one thing is remove all unnecessary stuff. That's the number one thing I'm going to say. The more holes, facets, stuff like that, the larger that file size becomes. So go in there and model prep the heck out of it. Remove all unnecessary holes, especially if there's threads. We hate threads. So that's my number one thing. Make the model more simple. Like even it wouldn't hurt to take that little chamfer out. That will help, not tremendously, but when you have 500 tools, it's probably going to play a big role. Okay, so I go in there, I can give it the EDP number. Again, I can tell it what it is, what tool manufacturer it is. Okay, so I go next. Here it says, what's the machine connection side? So this is where it's going to be a little confusing. If you hover your mouse, it's going to show you. I thought it did, maybe it didn't. Maybe you just click it. I thought it did, but yeah, there it is. But remember, we're not really in the adapter side. We're still trying to get to the holder. So this is why I want you guys to think about this. I want to make this match on both features. And this will make sense when I do this right here, okay? So if I come in here, I'm going to select this, and I'm going to look at it how it'd be sitting in the machine. It's actually going to be sitting in the machine like this. Like I'm going to look at both the adapter and the holder in the same orientation, where I want the insert over here to the right, just for my visual. Doesn't have to be. You can do it the other way. Okay, so I'm going to say I'm going to pick this face right here. So again, that orientation. I'm going to move this to be at the center of this hole, okay, just like that. And I'm going to point X over to that hole right there. If I can rotate it around, there we go. I'm going to point X to the center. Remember, C for arc center, that's the keyboard shortcut. I know there's no keyboard shortcuts for the auto function keys, but this right here, C's for auto center or arc center, O for origin, E for endpoint, M for midpoint, so on and so forth. Okay, that's all I need to do. Just remember where I set this at. Okay, so I hit enter. There we go. I don't really need to give it a workpiece type. This is kind of my thing. Okay, I don't need to align anything, so I just green check. So I brought in the holder. Now I need to bring in the adapter. So I right click on the holder. I say, let's insert a component above. Now we're going to bring in our adapter. Again, name the adapter, give it the EDP number, all that fun jazz. And let's go open that same model we just opened. This one right here. Go there. Okay, which one is it? It's that one right there. Green check. Okay. I didn't think this really mattered too much, but there are some functions where this rectangular size does matter for when going into a tool locator. Okay. So it is very important to make, because it could actually fit this into a different tool locator than what's required via the 1 inch. Okay. So go ahead and make sure you do that. We go next. Okay. Now what's the machine connection on this? The machine connection is the actual back. Okay. I'm not too worried about this orientation at all. So I'm just going to hit enter. The one I'm worried about, well, you can fill this out as well, you know, so we can do a square 1 by 1. This is for you to know. Okay. There might be some true functionality of it, but what's the workpiece connection? Okay. So I'm going to go here, and it does require a name, and you can name it whatever you want. I'm just going to start with connection, and I go into here, and I'm going to orientate this in the exact same view I did the other one. Okay. So insert to the right, looking straight at it. So I pick this face, and then I move to the same hole center, that one. And I point to the same hole, that one. Remember, I looked at it like this, but I was doing it on the back side of that face. One was this face, and the other one's this face. See what I'm saying? That's the difference. So when I do that, I just hit enter. I green check. Okay, and as you see, it assembled it perfect. So that's where it is. It's so hard to realize that, but just orientating that. And what we're doing is we're picking Z going off the faces that meet each other. So on the holder side, my Z went this direction. On the adapter side, my Z went this direction. That's where they mate. So it's just that simple. I know it can be a little more confusing, but there, everything's aligned perfect. Again, you can fill in the rest of this information, but I go there. And then I can go in here and I can define an insert. And then open the exact same model, this one right here. Okay, just like that, pick my insert. There it is. Again, all the same information. This is a left-handed tool. Go next. That is, just so you know, that is just like that one by one. This is something important. Make sure you're using the left versus right-handed tool. Okay. Go next. And again, if you didn't know, it's not going to let you proceed until you give it all the information it needs. In this case, it needs a corner radius, which not all models allow you to go pick it, but this one, I'm just lucky enough that it did. I always say with a lot of this information, pull it off the EDP or the manufacturer's website. Have it pulled up, because like right there, it says a 0.01422. Now, is that really, you probably know metric a little bit more, but yeah, it's a metric conversion. And that's another thing. If you don't know, we do metric. So 1 mm will convert it automatically, okay? So the same thing if you're working in metric and you go to inch, you type in whatever you want, IN, and it'll convert it into metric, okay? Let's go here. So we got our 14, all right? What's the width of this insert? Well, again, you can actually right click, which I'm actually surprised it's asking me out off of this. Let me do this again. It should have pulled it directly from the model. I think since I cleared it out, that was my problem. Go back to here. That's what I always do. I don't even fight it anymore. I just go back and reopen it. Why mess with it? Okay, go next. Oh, no, it still didn't. Huh. Again, I should pull that off the EDP website because I don't 100% trust models, but I should be able to go from here to here. Right click, distance between 2 points, right? So we're there. We go next. I don't need to assemble anything. We go in here to what's our cutting plane. On all bar holders, stick style tooling, it's always going to be this top face right here. Capto, stuff like that. You need to make sure you have a plane. Most of those models come in, bless you, most of those models come in with a plane already orientated in the correct orientation. So just go, that's what this will do, allows you to go pick a named plane. That one does. But this one, I'm just going to go pick this face right here. What's considered the top plane, which is that one right there. Okay. Now I like to bring this one up too. Two things, very important. Make sure your insert up direction is correct. The arrow is pointed up because this will wreck your whole day if that's going the wrong direction. Okay. So that's number one. We go next. So just like we talked about on the milling tool, we have the Mastercam define tool and the parabolic. The wireframe is what generates the toolpath. The solid is what we're going to collision check and what shows up in graphic screen. So what this does, just like old school, when you brought in a lathe tool, it just took a projection of everything. Well, in this case, gold is yellow is what we're going to cut, and blue what we're going to avoid. Well, since it took a projection of this, it found that tang, and that's given us a problem. So we want to limit what it's allowed to look at. So I want to come in here and go to change the boundary. And it's just, I can just tell it, hey, let's only look inside of this. But I will say, you have to be very careful. If there's a point where you trim and it leaves a solid detached, it'll alarm out on you. It won't let you do it. So just be very mindful of that. But yeah, I'm just going to come up here and say, man, let's bring this, and I'll bring it up almost to the tangency of my radius because really not too concerned. Okay, and then I'm going to bring this down about right there. See, right there. Disjoint body because it left a little, so you can make it work, but really going right there is perfectly fine. And you hit enter, and now you get a new boundary profile that's allowing it to cut, okay? So there's that. Go next. Now here's the most important thing. If you're working with a standard turret machine, a Puma Lynx, on a Doosan, Puma or Lynx, an LB, something that's got a turret mount to it, you want to align this thing how it's located in your turret. If you're a B-style head, a milling spindle, we want to put it in here, the orientation, how it comes at a tool change. Okay, so that's where you'll ever hear me reference that. It depends on what kind of milling, what kind of head mounting system we have here. So let's just pretend this is on a turret style machine. So I want to come in here. And in this case, it actually, honestly, would be the same thing. They're both orientated the same. But it is a horizontal tool. I automatically go to top view. And I forget about this too. The Gnome's been out since last year, 24, I don't remember. just click top. That's another way to get top view, okay? But orientate it in the correct orientation. So I always start with vertical and I automatically go here to clockwise, counterclockwise before I ever mess with reverse, okay? So now we're in the correct orientation of how this thing's gonna be loaded into my turret, or i.e. the tool changer, okay? Everything looks good. I go next. It needs to know what quadrant. In this case, I'm gonna do quadrant 4. Some people wanna pick quadrant 1. It's your choice at this point. And we're gonna go pick what's our intersections from here to here. And see everything moves down. It looks great. This is stuff you should already know, but I do like to bring this one up, especially. This height right here is extremely important on this one. And it's due to the fact, well, zero that out. This height, it's actually this height right here, is very important because when you go do a grooving and you do a 75% step over, this is what's calculating, at least the way I understand. This is what calculates that. So if you leave it 0, it's going to be 100 little tiny moves, like 1,000. So very important you come in there and give it that value. Yeah, I'm just going to come in here and go from here to this point. And again, I'd pull this directly from the EDP, so on and so forth. All that fun jazz. And the other one, if you're doing like a standard CNMG or something like that, your side clearance do matter, because the way, again, I understand this is whenever you do like a plunge cut and they give that back angle, that's what it's getting calculated from. So it's very important you give it that information. Okay. So go next, calculate your feeds and speeds, so on and so forth. We can just green check, and there you go. You have a successfully created 3D tool. So the reason I bring this up is let's just go throw a quick little groove on here, right? Let's go grab groove, and what Jesse said would have been nice, just wouldn't have done anything, but is what it is. Oh, wrong one. And again, you guys know me. I am a big proponent of solid chaining over wireframe. You're going to probably do the shift click, right? Do you have that? Yeah, I'll let Kyle do that one then. Okay. No, I don't need it right now. I was just going to bring it up. Okay, so we're going to do that groove. I'm going to pick that tool, which I'm going to turn my library tools off, so I grab just that tool. And I'm not going to do anything but just green check. Oh, I picked dynamic rough. Who let me do that? Why don't you guys yell at me? None of you guys? Just let me look like an idiot, which is pretty easy to do. Okay. So we go from there to there. Pick that tool. I'm just going to green check. Okay. Looks good. Let me do it. But when we go in here and we run our verification, we're going to stop on collisions. We will see. We do not. I must have moved that on me. But I thought I had it correctly, but it'll actually alert you saying that you have a collision with the tool holder hitting, because it's looking at that 3D tool now. So I think I can't remember what I did last night. So, but yeah, that's fine. Okay, let me jump in, because I know you guys don't care about this. You care about unified stuff. That's the stuff. Any questions on that, by the way? Any questions? Anything that I didn't answer there, or questions you might have? Nothing? Okay. Let's look at a quick unified thing real quick, okay? Now, I'm not diving in super deep. I'm just trying to show what makes the most confusing thing. Everybody gets confused with unified. Most of you know how in love I am with this toolpath. I think it's the greatest toolpath in the world. But I want to show you it's a lot easier than you think, and you don't need to really worry about tool axis control. I'm going to show you some collision control, a little bit of linking. Kyle's going to go into more tool axis control. But I'm going to show you can make some pretty good looking toolpaths by just using collision control. Okay, I want to come in here and I want to clean the floor up of this part right here. Okay, so if I come in here and I grab unified, I've created a couple tools. I've got this 1/2-inch ball nose. I've already created it with a holder, just for. This is very important when you're using collision control, that your holder matches what's there, okay? So let's go here to our cut pattern, and I don't know why that's defaulted on. Again, if you don't know my strategy, is it cutting what I want, how I want? Is it a tool axis control how I want? Is it avoiding what I want? Is it getting in and out of the material I want? I preach this. Do these steps. Don't try to go ahead of it. We all want to hit a home run with hit the green check and never get back in the toolpath. This is not one of those toolpaths, okay? Just so you know, this is one we have to walk our way through. Too many variables, and you're going to kind of see it here. First thing I'm going to do, what do I want to cut? Well, I want to cut that floor right there, okay? How do I want to cut it? Well, I could go in here and do a bunch of stuff, but really, I've come to like this automatic on instances like this, okay? That's all I did. If you noticed, I picked what I'm going to cut, how I'm going to cut it, and then I am going to go ahead and change this just to a spiral. Okay, I'm going to spiral. That way we don't have to retract up or anything like that. And I will tell you, default your unified to be 5-axis surface, and I want your collision controls, all of them off, okay? That's all I want you to do. And we green check, we look at it, okay? Or blue plus, I'm kind of behind the times. Is it cutting what I want, how I want? Yes, okay? But unless you have a really good weld department, you're probably gonna need to change this a little bit, right? Because there's a little bit of problems here. But we're gonna work our way into that, okay? One thing I noticed is starting on the outside, I wanna start at the inside and work my way out. So I'm gonna address one thing at a time, okay? So I jump back into here, and all I gotta do is flip the step over, okay? Here's one product enhancement. Matt, you might write this down if you want to, obviously, is the blue plus is amazing. If you guys don't know it, the blue plus automatically calculates our toolpath here. But I wish there was a quick back plot button I could hit instead of getting out of the toolpath. Like if there was a button here that I could hit to just do a quick little back plot would be amazing. Because right now, if I want to check it, I got a green check and get out of the toolpath, and then I can run back plot. But see, now you see I'm starting in the center, working my way out. Okay, so 1 and 2, cutting what I want, how I want. Yes, everything looks beautiful. The next one, tool axis control. Well, typically you spend a little bit of time on here. This is what confuses most people, is tool axis control. Here, I'm just going to leave it as surface. All that means is the tool is going to stay perpendicular to that surface, okay? That's all we're going to do. Kyle's going to spend a little bit of time on this. We're going to jump right here to collision control. You can do so much with collision control, and I don't even have enough time to talk about all the different things you can do. I'm just going to go over just a couple ones real quick. I'm going to come in here, I'm going to turn this on, and I'm going to say, this is the order it goes, by the way. What do we want to check against what, and what do we want to do with it? So it goes in that order, from here to there to there. That's the way I like to show that. So I want to check the flute, shoulder, shank, and the holder of my whole assembly. I want to check it against, let's just start by coming in here and check it to an avoidance region, this, and then we typically think we just want to come pick all this internal stuff, right? That's the way I would think, straight out of the box. Nothing wrong with it. This is also just going to prove to you just got to try a couple different things, okay? That's what I want to do. Green check. See what it's going to do. And you can see, oh, sorry, I got ahead of myself. I need to change what the collision control type was. I'm checking this to that. What do I want to do? I want to tilt the tool, okay? Automatically tilt the tool in whatever direction you feel necessary, okay? And it did pretty good. I'm not going to say it's not bad, but if you're like me, I don't like lift ups and stuff like that. I cannot stand that stuff. So what I'll do is I'll come in here and I'm going to add an additional collision control. So if you don't know how collision controls work, if one addresses it, 2 cannot, okay? So in this case, tilt tool resolved a lot of problems, but what's left over, I want to address it with another collision control. In this case, I only want to check it against the flute, and I'm going to say, let's retract the tool to cut center. See, because we can retract the tool in all these different orientations along our tool axis. We're going to use that here in a second. WCSZ positive, XY plane. But the one I like, besides along tool axis, is just come in here and to cut center. So it's really going to push everything in. So if you don't know, most people use trim and relink a toolpath. Trim and relink a toolpath, what it does is whatever the collision it sees, it literally cuts the toolpath off right there. And then it has to relink it, right? It doesn't do anything but cut it all off. It's like using a pair of scissors. Where a retract tool, especially in cut center, it says I'm going to avoid that. Instead of cutting it, I'm just going to move it back in and move it back to the cut center. See what I'm saying? So this is where we can do a lot with this. So I'm going to come in here. And actually, I need to come in and delete this stuff. So I'm going to go here, and I like to pick the outside just to be safe, okay? Don't give it any chance to come in from the outside, okay? So we get right there, there, and there, okay? Then my retract tool is going to be against these on the inside, which you can actually hold shift and click, but it picks way too much for my opinion. I don't want the bottom radiuses or anything like that because I'm using a 250 or a 1/2 inch ball nose, and that's an 1/8 inch radius there in the quarter, okay? So we go just like that. So retract the tool to the cut center of the part. There you go. Look how much that cleaned that toolpath up. See, we just turned this into a really nice looking 5-axis toolpath by just simply using collision control. So the tool is going to come in, it stays vertical. You can add lead lag if you want or side tilt, but just look at that tool. It's just kind of dancing around. Let's get to right here. Let's hit play. Okay. By think of it like this, just give it its limitations. By me picking the sides of the parts, I said, hey, you can't tilt out there. Because again, the toolpath doesn't know it can't go there because I haven't told it anything. I didn't say it was machining geometry. I didn't say it. But there is a point where you can give it too much information. So this is one of those things you're just going to have to mess with, okay? But see how simple we just made that toolpath. And that's going to look pretty nice running out there on the machine. Okay, but as you can kind of tell, we're using a 1/2-inch ball nose with an 1/8-inch quarter radius there in the corner. That's not going to work. But what we've done is we've at least cut the whole floor. I do want to bring this up. This was a function that came out in 25. A lot of people don't know. You see this right here? You're like, oh man, that looks like crap, right? Well, because remember what this is showing, what the blue's showing us is the tool tip, the point on our tool. So if we're kilted over, that could be 50, 60, 70 thousandths. Actually, if you look, if I rotate, you'll see some of that's coming up off the surface itself. And see right there, by the way, do you see what I'm saying? It didn't trim the tool path, it just brought everything back. It sucked everything back into the cut center. So we're not wasting motion, we're not having to trim and relink or anything like that. But to go back to this, what's it actually look like? Well, underneath advanced toolpath display, there's tool contact point. This came out a while back. If you look at that, it actually projects onto your surface where the contact point of the tool is. This only applies on all 5 axes or just unified, I can't remember. All 5 axis toolpaths. Yeah, anything that has vector data. And if you don't know what Kyle's talking about, what you want to know, if you go into your back plot, go into your exclamation point, here's your vectors. You can display all your tool vectors. Like when it runs, you can display it outside of back plot, but you can see where all our vector changes are happening. So anything that has vector data, you'll be able to see that. I think that's a really neat little function, but it's only available in your advanced toolpath displays. It doesn't show up in backplot, which I wish that's one thing they would add. But as you can see, you can kind of see where I'm staying away from, but they are still unified, even though the motion of the tooltip center did not look correct, okay? So that's a nice one to have. Okay, so how am I gonna clean these corners up? Let's go in here and let's just grab this toolpath and throw it down here. Make it easier for you to do your job. You don't need to reinvent the wheel every time. I already have all the information I need in there. So I'm going to go into this unified. Okay. And all I'm going to do, the first thing I'm going to do is change the tool. I'm going to use a 1/4-inch ball nose. Okay. Now, instead of doing an automatic, you see how nice automatic was. 2 years ago, I wouldn't have been caught dead using automatic. But once I started realizing it is pretty powerful. It takes a lot of that guesswork out. But for this, I'm going to come in and I'm just going to stay parallel. Whoop, let me do a face right there. Stay parallel to that, okay? So I don't really have a good definition. Kyle, if you do, please preach up between the advantage of when to use guide versus parallel. I'm just an old school guy. I like parallel. I know the push is guide. I've not gotten good enough information to really give you hey, use guide over parallel, okay? But they technically do the same thing. And I need to get a little bit more from Mastercam to find out the definition of that, okay? But here, what I want to do is I don't want to cover the whole surface again. I'm going to come in here and I'm just going to say, you know what, let's just do this determined by number of cuts. I'm going to take 15 passes at a 20 thousandths or 15,000 step over, whatever I want, okay? This is kind of neat. I left all of this alone. I didn't change anything. And I go in there, and now that's how I can go in there and I can just blend that radius in. I didn't have to reinvent the wheel. I didn't have to do anything. But one thing I might change instead, because now I'm not worried about that tool hitting these top walls, right? I'm trying to blend that into that radius. So I'm going to change my one collision control to be retract tool along tool axis if I come in contact with these radiuses. And I probably could have kept the walls as well, but it's not the end of the world. Just like that. So now I'm forcing my hand. I'm not allowing my tool to violate that floor or that radius. We should blend really nice into that radius. And we still have the same tilt to avoid. We still have an awesome looking 5-axis toolpath. I do need to flip the step over because see, it's starting there. So again, that's just a flip step over. Okay. I'm not getting on these. I'm not getting into the lead in, lead outs because I am going to kind of do that on the next, my last toolpath for the day. You guys get to quit listening to me, but there you go. As you can see, it's just going to nicely blend that in. And if you get to it and you're just like, man, it didn't quite blend, just add a couple more passes to it, remove a couple passes. But this is a good way to get a tool in there and do as much as you can and come in and blend with the rest of that. Any questions on just this right here, these two? Any questions? No, that's good. That's a win. I do want to bring up, let's say we go cut this face, because it's something a lot of you have to fight. And I was just with Casey yesterday, we were talking about circle segmented tools, okay? So let's get into a quick little circle segmented tool thing, and it's to cut this face right here. To me, that is the future. And Christian can probably vouch to that as well. Circle segmented tools are becoming more and more popular. If you don't know what circle segmented tools are, they're lens cutters, taper mills, barrel mills, and ovals, right? Those are your four. I can't tell you the exact time to use each of them, but there are documentations out there. But the advantage in they're, well, let me just, how about I'll just pull one up? That'd probably be easier because I have one right here. Let's go into this Unified again, and you see I've got this circle segment tool that I just found in one of our libraries. And what it is this is in theory, a 1/2 inch end mill. I think it's a 10 millimeter or 12 millimeter, but it's got a giant radius on that side. Okay, so now we're going in and eliminating ball nosing with these little step overs with bigger step overs. In this case, this lower radius right here is a 9.8 radius. So it's like we're cutting with a 10-inch ball nose in there, but in a little tiny. So that's where you can take your actual calculations from for your scallop height, okay? So I will show you a quick little trick you can do to establish scallop height, and I'll show you, but let me create the toolpath first. So this one's very simple. We're just gonna come in here and yeah, I guess we can do that. Let's just do morph. And for some reason, my second color never changes for me. So I just go in there. I wanna morph from here. Let's do the individual chain. I wanna morph from here to here, okay? We're gonna morph, and then I'm gonna cut this surface. So again, same thing. Is it cutting what I want, how I want? Well, I'm gonna go back to the full avoid. I'm gonna do a one-way, and I'm gonna do like 100,000 step over right now, okay? I'm gonna reset all this. I'm gonna turn this off, because remember, it looks at your previous operation. You can turn that off. All that looks good. So again, green check. Is it cutting what I want, how I want? In this case, yes, it is. It's cutting the surface I want, the direction I want to cut it, okay? So if I can get, come on, mouse work for me. See, it's starting where I want. It's cutting the wrong direction, but I'll a lot of times fix that at the end, okay? My step over messed up on me, but going here, I guess it's still 100. That's fine. Okay, you could probably do more. One thing you do need to note is when you look at your tool, you do have to get this from the actual manufacturer. They're going to tell you, like in this taper mill, what the actual angle is. In this case, it's 20 degrees. So that's telling you what my tool axis control needs to be. It's telling you in the title. So when I go in here to tool axis control, I'm going to change this to surface with tilt, which is what 90% of everybody uses, okay? And I'm going to go in here, and 20 degrees is really 70 degrees because it's 90 minus 20. So I'm going to do a 70-degree side tilt. Green check that. And as you can see, there's my tool path. See it? We're maintaining that 20-degree side tilt angle on our tool. Okay? I mean, that's pretty much the tool path in a nutshell, but I want to show you, this is kind of the next step that I want to show you that can clean these things up and make really nice looking tool paths. That motion's not the end of the world, but it's not super clean. It's a lot of machines aren't real good at doing multi-axis motions and rapids, right? They're not a fan of that. So watch what we can do just using our linking parameters here. Okay. Collision control is fine. I can go in here if I really wanted to. I could say retract the tool, but really there's nothing I'm trying to really avoid there unless it gives me a problem. But if we go here to our linking parameters, now I do understand I can come in here and just make my gap a little bit bigger, but I'm lazy. I'm just going to go ahead and say all large gaps. Let's go ahead and just do a, let's leave that off for right now because I want to show you that first. I want to use a lead in and lead out, okay? For all large gaps, I want to use the lead in, lead out, which is what this is. And I'm going to come in here and I'm going to turn my lead in, lead out on. And I'm going to go do a vertical tangent, or I'm sorry, horizontal tangential arc. And I'm going to say 90 degrees to start with at 100% diameter. Okay, green check, or I'm sorry, kick it over and blue plus. So you say green check. You can see now we have these nice roll-ins, but we still have all this really weird motion up there. I got to quit hitting this thing. All this weird motion up here. Well, this is what's so cool about this. Go change that linking style. Instead of retract to a clearance, just say blend spline. Blend spline makes lines tangent to itself. So we're coming off like this. It's going to create a tangent line. Why use my hands when I can use the software? See? Literally just creates tangent lines. So it's really smooth. Well, that's a lot of movement up there, right? Just go in there and change the angle. Let's go to like 140. Let's see what that looks like. And now look at that. It doesn't seem like much, but imagine this running on your machine. Think how much smoother this is going to look, okay? You're almost doing like a helix bore of some sort. It's just nice, smooth motion for your machine. If you want to make those corner radiuses a lot more, go ahead and do that. But one problem, let's say this is titanium, and I'm cutting this, you know, I don't know the titanium feeds and speeds for this. I'm not going to put you on the spot this time, Christian, I promise. But I don't want to run real slow through here. So that's what's really neat about this. And again, I could spend a whole nother hour just talking about this section too. If you do have questions, let me know. But right here in feed rate control zone, I have links between slices. I can change the feed rate between my slices to something completely different. So I can come in here and say, let's do 500 inches a minute. Okay. So I am going to steal your thunder on this one, Kyle. I'm sorry. But if you go to home, a cool one that most people don't use is Analyze Toolpath. It's actually F3. If you do that, you can hover your mouse over it and it'll show you all the information at that exact point. And in this case, it shows me my feed rate is 100. But look, when I come up here, we're up to 500. So all controlled feed rates, nice cut motion, come up here 500 inches a minute, back. So you can see how we can really create a lot of really smooth motion. One last thing I'm going to do, and I'm done, I promise, is my lead in, lead out for the start and the end. What if I want something bigger? Okay, well, if you didn't know, you have that ability in all unified toolpaths. Is watch this. I'm going to use the lead in, and I'm going to use the lead out. Well, look, it gives me now an option to do a first entry lead in and a last exit lead out. I can have them completely separate from what I'm doing on the other ones. So this one, I'm going to say, I want this to be 90, but like a 250. You know, something like, that's a little big. My big old fat finger's getting in the way. Okay. Same thing with the last exit. Same thing. 90 and 250. Just like that. So now I've broken up all that. I've got a nice big lead in, a nice lead up. Maybe I don't need the arc. Let's just get out of there. We'll do that for your last lead out. But see, we can change so much stuff and make a lot of really clean motion using these little tiny settings. So my challenge to you guys is try it. Try it, but try one thing at a time. If I'm going to change it, try it, see what it does. Because I promise if you change 2 or 3 things, it affects too much. Okay? Look into the collision control. If you have questions, reach out to me, reach out to Kyle, reach out to Sam, reach out to any of us, Mark, John, all of us. Okay? We're here to answer those questions, but those are the things you can really fine tune these toolpaths with collision control. You saw right there, we made a really nice looking toolpath with just using collision control. And there's a lot more you can do with that, but with that, that's really all I've got. You guys have any questions for me? We are going to do a little Q&A around lunch or after lunch, so if you have questions, if you want to just come talk to me individually or Kyle individually or any one of these guys, just come up. But other than that, that's kind of the first half. We're going to take a little 5-minute break, switch computers over, and yeah, other than that, if you have any questions, let me know.
How's it going, everybody? My name is Kyle Mills. I have the unfortunate task of following Justin. He's with our headliner. We got mixed up here, but I'll do my best to show you guys what's new and a few tips and tricks as well. So Justin kind of showed you through the first half of what we found was, you know, kind of the latest and greatest of 2026. I'm going to guide you through the second half. To start, we're going to do something that I really like. For those of you that are familiar with the toolpath waterline, you know, they have critical depths in there. We've now added that to OptiRough, which is excellent. You don't have to rely on step-ups anymore to go back and do all your floors. You can actually just click on those levels. So I'm kind of like Justin in this regard. I have a bunch of slides, but I'd rather just show you. So we're going to hop right in. Get out of this PowerPoint. I'm also not a very proficient in PowerPoint, but here we go. All right, so I have here just a normal toolpath, a dynamic toolpath, and you'll see that we've actually added this field down here, critical depths, just like waterline. So you can go in and you can turn step-ups off. You can go in and just pick those critical Z levels that often get missed by the normal step down. So to illustrate this, I'll just do kind of a bigger step down here. So maybe we'll do like 400%. Calculate that really quick, see what it looks like. Because sometimes it might be the case that your tool can handle 400%, 300%, some of these bigger step downs, but you still want to go back in and do those levels that are important to you. You see, that gave me all of one step down. That's probably not going to cut it. So I'm going to go in and I'm going to turn on our new feature, critical depths, right here. And I'm going to say include flats. There's a automatic way to do it where the Mastercam will look through your part and just find those flats, and there's also a manual way to do it. So you might have some feature that you really don't care about getting, it's going to clean up later, and you might have something that you want to do, and that's where manual would come into play. And you may just want Mastercam to take care of it and just do all the flats for you, and that's where the automatic include flats would come into play. I'm going to go ahead and hit green check on that, and we'll see what that looks like after it calculates. I always go in here and hit high. I think it just makes me feel better to put it on that high processing speed. I don't know if it actually helps. It's the feel good button, exactly right. So now you'll see that I've recalculated that. Instead of having the one pass there, I have one at the top flat and I have one at the bottom flat. Nice and easy without having to turn on my step ups. So if you were trying to rough something out really fast and you didn't want to worry about going up that angled wall with step ups, you could quickly put this on here and still include your flats without having to play with your step down, which is a great addition in my opinion. So let's do this one more time, and this time we'll just do a manual. So I'll say manual flats. And this is where you can actually use the cursor button and just pick, which flats you want off the model. Grab this really quick, and I'll just grab the bottom here. Green check. Green check. And now it should omit that top one. Maybe that was already done with the facing tool, and it will do that bottom flat for me once it's done calculating. Probably should have made my step over bigger, but way it goes. Turn our feel good button on. Perfect. So now you see I have my two step downs, even though this doesn't really fall into that 400% of the tool diameter step down, it's going in, it's doing that flat that I picked. The next one I want to show you kind of plays off what Justin showed you with the planes manager. So once again, this is one of the bigger changes, the visual update. So let me grab that slide really quick. So you'll see on the screen here how they've kind of done a different layout. Now, a lot of you are probably cringing at this. A few of you may be excited to see what's new. I genuinely like the way it looks now. If you remember the old style, I can't tell you how many times, because we switch screens all the time training people, and you guys probably switch screens when you go work from home, you go back to the office. I'm constantly dragging and dropping those little columns back and forth, trying to resize it. If I go from a 4K screen to a 1080p screen, I'm having to resize it again. The nice thing is, like just with the planes manager, it stretches and it goes in that area that you want. So instead of looking through all these slides, let's show you in the actual software. Let's take a look. Go to my parts, signature parts here, go to our levels. Give this an open. Oh, thank you. So you'll see I go to my levels manager, and I've made the size a little bit bigger so it's easier for everybody to see. You can see it's pretty clean looking. There's not a lot of extras there, but all the detail that you're used to is there, and a few extras are packed in there as well. So we still have the level numbers. They're here on the side. What I really like is the huge green check. How many times have you gotten confused on which level is actually active, and you're making your wireframe and you're not sure? Green check's microscopic. They made it a nice big green check, so great job, Mastercam team, on that. Some other things to note, just like planes, we can group things now. So it's kind of moving towards where we're not having to remember the number series anymore. Like I used to always do 1000 is always my solids, 2000 is always wireframe, 3000 might be stock models, meshes, and things like that. You no longer have to worry about it like that. Even though all your legacy stuff still comes in just the way you had it with your numbering system, we can now group things. So let's say if I wanted to group all my fixturing into a folder here, I can actually either hit the plus sign up here and add a new group, or I can select what I want, right click, and group those together. That adds a new group, and I can rename it. You can either do a slow click or right click rename. So slow click does work here too. So I'll say fixturing. Me and Justin Spelling are right on par with each other, so please forgive me for anything of that nature. So that's really cool, right? I got it in there, and now I can collapse it. It's out of the way. It's categorized, and I know where to get it now. It's in my fixturing tab. Some other things we've done in talking about, getting things organized is we can also search in here. So say, I don't remember what group I put my fixture in. I actually just need to find it now. I can just go up to the search bar, and I can start typing in fixture. And you'll see, as long as I've named it with something like that, it just pulls it right up. It's there for me. It's ready to grab. I don't know about you guys, but I used to be a mold maker, and we'd have, hundreds of toolpaths in there. And with those hundreds of toolpaths, you get hundreds, maybe thousands of levels. This would have been a great tool at that time. So I'm really excited about that. One thing that's a little bit different is we don't have that property page that you saw before, where you could just type in numbers and hit enter. So that's a little bit different of a workflow that some of you may have to get used to. But like I said, you can group everything now. So we'll go ahead and just delete this out. And with that grouping, we can also do a filter. This is one, get out of here, Grammarly. Let's put that over there. You can also do a filter, and this is actually one of my favorite things. I don't know about you guys, but when I have a certain amount of things turned on in the level, sometimes I want those to be at the top so I can actually see what's on, instead of having to scroll through everything and seeing what has the I mark on it or the X as it was in 2025. So one of the really cool things is I can do level visibility, and then I can do descending, and that turns everything that's on currently to the top. So as I'm turning things off and on, it's putting them right to the top. I absolutely love that workflow. I get to see what's on. I use that in tandem with view sheets, and I can see exactly what I'm working with. With the filter, we have quite a few options. We still do level number, just like before. We can do name. We can do entity count. So if you have something that has a ton of stuff, maybe like a wireframe level with all your wireframe in there, you could get that to the top. You can also, just like planes, drag and drop this wherever you want. So no longer are you pigeonholed to the numbering. You can just grab it, move it wherever you want. So I can go over here to my fixturing, grab it, drop it down, below here, and there it is. It's down below there, out of the way. So very, very similar to how the planes is set up. It's very streamlined that way. Not only that, we have the filter. The filter allows you to grab your different groups very quickly. So if you didn't want to, if you're lazy like me and you didn't want to type out the word fixture, you could just go in here and say, hey, I just want to turn everything off. And then grab my fixturing, hit OK. And now I'm in that folder, and I can grab that nice and easy. I'll go ahead and clear that out. There we go. Something else that they've added, just like in the Planes Manager, the 3 dots also gets you to the right-click menu. So you still have all those same options, move selected entities, select selected entities. Those are all still available to you. Not only that, you'll notice that the way we turn off and on our levels is a little bit different. We have this eyeball icon now. So you can see as I turn that on, the eye is open. When I turn it off, the eye is closed. Another little caveat with that is if you have a group with a mix of things that are on and off, it has a different icon for that too, to show you that there's a mix, which is right here. So some of the things in the group are on and some of the things in the group are off. Very visual, very easy to see, especially if you make the font bigger like I did. It's nice and easy to see. Any questions on the new Levels Manager? Oh, absolutely, yeah. So before we move on, another thing you can do is inside the Levels Manager, you can see what types of geometry are in the levels. So if you have a whole bunch of things mixed up in there, you can actually just expand this, and you see I got some drafting, I have some solids. Let me grab one that has a bunch of stuff in there. Let's see. It's got some lines and splines. So you can see as I expand these, you can see what's in my containment. I have lines, I have surfaces, I have arcs. Another cool thing is in your configuration, you can have these auto highlight. So if you're wondering what that surface is in there, I can just go simply over here and let me turn this level on, turn this on, and I can just hover over that and it'll show me. So you see how it highlights the lines there. And this is another really great way to sort things further. So for me, I like to put my solids on one level, my surfaces on another. So I can grab that very quickly and rapidly without even have to go to the quick mask over here. So I can just come over here. I can say, hey, I wanted to just select all my lines here. And I can move that over to the field that I want. Any questions on the levels manager? Let me get you a microphone. Here.
He asked, can you import a template? That is one thing. Yes, you can.
Yes.
So I know a bunch of you guys create Excel spreadsheets that have your templates. It will bring those in. You still have the same import. Like if you right click, Kyle, you still have the same functions and
It's all the same, right?
import name
Yep.
levels.
Mhm.
And like you said, it is going to bring the legacy stuff in. It's nothing will change. It just doesn't group anything. So yes, you can.
Really the main difference is how you create the numbered levels. That's just a little bit different. So the way I used to do it is I just type in the properties down below, like in 2025. And I got a copy of 25 open right here. So what I used to do is just type in this little number right here and that would create one for me. That's no longer an option. It's just a little bit different in that workflow. Right. Find our next slide here. So another addition that they've done in keeping with the organization, making things a little bit easier to pick, is does anybody remember the really old verify selection? It was up in the auto cursor bar. Don't worry if you don't remember, almost nobody remembers. Oh, I see one. Oh, that's a record right there. We got one. So how'd you like using it? Yeah, that sums it up. Yeah, it was there. So I'm gonna open up the new verify selection. It's pretty cool the way they packed it in there. You no longer have to go to a separate button. It's just one of the hover features now. So kind of like auto points, you get kind of an auto verify. Let's dive in there and take a look. Right out of here. Oh, might help if I go to 26 here. There we go. Pull out. Okay, so I have a pretty complicated part here where there's a lot of different solids, surfaces, wireframe, all on top of each other. And as you guys know, sometimes it's hard to pick the thing that you want, right? What they've done in 2026 is as I hover over here, you'll notice I get a different little icon on my cursor. It looks like a few pages on top of each other. Now, you'll also see that there's 1 out of 7 below there too. That means there's 7 possible options that I can pick from where my cursor is currently at. Now, if I were to right click right now, I get all these as an option. So I can actually cycle through and you'll see it makes things transparent so you can actually see what you're gonna grab as you're going through. And you can use the arrow keys as well. You see how it's making everything see-through and you can roll the model around when you're doing this. So let's say I want to grab this middle section right here. Now I can just double click on that and I've grabbed that in the middle. Just from hovering my cursor over the middle of the part, I grab something in the center. So honestly, great if you have an assembly and you have some sort of thing that's inside of your model that you're trying to pick from. Maybe you're trying to put it on a different level. Maybe it's in the way. Maybe you don't want it to be a part of your roughing model because it's slowing down your OptiRough. There's lots of different applications for that. But yeah, that's really it for that one. It's just nice and easy to use. You just hover over a section. It tells you how many entities are there. So this one says 9, and I can just kind of go through and pick what I want.
I will bring up, just so you know, there is settings in the configuration file to change the size. And correct me if I'm wrong, if you can do this different shading colors for this function. So it
I
is
think you
something-
can mess with the
the
translucency.
translucency
Yeah,
of it, but
you
yeah,
can mess
that
with
is
the
through
translucency.
configurations.
The next one I'll go over is we've done a little bit of a change to the reference points page. Anybody ever use that? Probably especially my 5-axis guys, if they want to get out somewhere nice and safe at the end of a toolpath. They've done a little bit of work, so now you can use the tool plane instead of just the WCS. So how annoying is it when you're doing 3+2 and you're doing one side, you get the spot you want to retract out all done, and then you go to the other side, it's like, okay, I copy that over, now it's going to crash through my part to get back over there. Now you can actually use the tool plane as that. So if the tool plane's centered and you just flip around your tool plane and C plane, it's gonna do the right thing. So let me show you what it looks like in 25, and then we'll do one in 26 as well. So I got this part here that's partially programmed. You see we're at this point here. I'm just going to do a few contours. I'm going to do one on one side and one on the other. Tool pass, contour, go in the climb direction, grab that, grab my 12 millimeter. That looks good, looks good. And I'm just going to go ahead and just make sure my planes are right. So I'm going to use top. I'm going to do 3+2. So I'm going to use the front for my tool plane. And then I'm just going to go and visit my reference points. And like Justin said, this apply button is your best friend. Just keep hitting that as you change things. And we're going to pick a different reference position. One of my favorite tricks that I like to do all the time is actually something that Justin showed me here. If you want to pick a point that's relative to a different point, because obviously the engineers don't always put stuff from our work offset, right? They put it from their own datums. Here's a little trick. So I'm going to go ahead and do some reference points at the start and beginning. And I'm going to just pick this select approach point. And I'm going to hold the shift key down. And I get a little gnomon. And now I can pull this out wherever I want for a safe retract. So we'll just pull it out something nominal here, 130 millimeters. Give that an update. Everything. So for those of you at home, Justin was saying that works for everything. If you're in a creation mode, if you're just making a point, you're making a line, you can hold that shift click. If you're picking for grabbing a part on a POCO operation, you can pick it that way as well. Yeah, exactly. And then I'll just copy this over to my retract as well because I want it to start and end at the same spot. So you see, that's pretty easy. That's a nice, safe way to get it out so that when we go to the other side, it's away from the part, okay? Now, let's go ahead and hit the green check. I'm going to copy this. I'm just going to change a few things here. So first thing I'm going to do is I'm going to go to toolpath type and I'm going to grab on the other side. Climb direction. Perfect. And then I'm going to change my planes around. So instead of front, I'm going to put back. My toolpath there. And you'll see already that I'm plowing through my part because it's going to that same spot, right? It's going off the WCS. It's going off the absolute. So of course it's going to go over there. So what I'd have to do in this case is, you know, maybe just flip a few of these around. Maybe I can just flip these to like positive numbers or something like that. Or maybe I have to pick a new point. It's a little unclean because, you know, especially the way I picked it, I just grabbed it and then pulled it out a little bit. So I don't know if it's going to be exactly the same on the other side. So let's take a look at what it looks like in 26 now. Let me open this up. One thing I will do is just put my wireframe on the other side so it's easy to grab that on the next one here. Cool. So I'm going to do the same thing. I'm going to make a contour and we're going to flip it around really quick. We're going to do it on both sides, just 3+2 programming at its best. Grab my wireframe. We're going to pick it in the climb direction. Going to pick that 12 millimeter tool again. Going to make sure our planes look good, so everything looks good for this one. And then we're going to visit our reference. So you see the layout's a little bit different. It's a little bit more streamlined, and we have a few more options in the dropdown too. Not only a visual change, but there's some functionality in there as well. So I'm going to start off by picking this the same way that we did in 25. And I'll show you that new functionality. So we're going to turn on approach and retract. And I'm going to just go ahead and pick a point like I did before. So I'm going to hit the cursor button. Just going to pick a spot out here. I'm just going to pull that out. We'll do that same 130 out there. And I'll copy that down. So you see, you get the same result there. Now, here's the biggest change that I want to do is instead of using absolute world, we can use an absolute for tool plane. So for 3+2 programming, this is excellent. So if I flip this around, instead of using the front plane and use the back plane, it's going to automatically figure out that it needs to go on the other side because it's no longer being controlled by that top plane or that WCS that you're using. So I'm going to go in here to my incremental or absolute tool plane. I'm just going to repick that, just be safe. Go out to 130, 131, sure, looks great. Copy that down. Give that an update. Okay, looks the same there. I'll go ahead and green check that. And then I'm just going to copy my contour, copy after. Go my parameters. We'll flip the planes around. So instead of front, we're going to do back. And then I'm also going to change up my geometry to the other side. You'll see it flips it around the other side automatically. So I didn't have to go in and reinvent the wheel on that. So if you're doing a lot of 3+2 work, that'll save you a lot of time, especially if it's something where you have a lot of flat lands that you're using 2D toolpaths for. It's a great addition there. Any questions on the new reference points before we move on? Awesome, great. Let's go here. So everybody familiar, everybody at least on 2024 here or seen 2024, 25? Anybody familiar with the graphical planes you can change the depths with? They've now added that to lathe in the drilling. So at least for me, I'm a mill guy. My last name is literally Mills. Drilling just makes my head turn. So on this, picking that depth is sometimes hard, especially when you're on a subspindle. Am I going positive? Am I going negative? How am I working this? If it's a mill turn with a B-axis head, how do I need to put that into the software? Those graphical planes really just eliminate those questions because it just shows you exactly where it's going to go before you hit go. So that's a really nice addition. I can't tell you how many times it's telling me, hey, you're starting embedded stock. I'm not going to show you anything. You're started embedded stock. I'm not going to show you anything. This gives you a nice representation. So I'll just do this one really quick. Let's open up a toolpath here. Change this back to standard freedom units. Here we go. So now if I were to go into a drilling operation, I can now turn on these graphical planes. So I'll go to the second page where you can see the different layout here, kind of like you'd see in the milling side of things. You can turn on each one of these. So if I wanted to turn on this graphical plane, you can see I can just change my depth by grabbing this and pulling it on in. So I can lock it to there and I know I'm good. That was always a bit of a struggle, at least for me. I don't know about you, Justin, but that was always a struggle for me is knowing where that depth was actually going to go. It's very visual too. So not only do we get that, we can turn on our drill point, we can turn on our clearance, we can turn on our retract, we can turn on our tool compensation, and we can adjust all these on the fly with these graphical planes. So let me grab this and I'll put this in a bit of a sectional view here. So I got our new planes here.
While he's doing that, I will say where I think you're going to see the win in this is subspindle work. How many times that confuse everybody? Working negative versus
100%.
positive subspindle.
Subspindle work confuses even me, even though I've done it a million times. You got to switch it up from going to a negative value to a positive value. And it's like, wait, no, but I want to drill into the material. Okay, but that's technically positive on this machine. So let's take a look here. So I got this kind of in a sectional view, and let's just take a look at how easy this is to impact now. I'll turn on my tip compensation so we can see that. And the tip compensation is showing you where that final point is going to be of that drill. So I like the way they did this. Unlike mill, they show you kind of where it's going to go to full diameter. This shows you where the tip's going to be. So if you're worried about going into the wrong spot, it's pretty nice. So I'm going to just pull this up here, maybe lock it right there and hit the green check. And you'll see, I'll give you more of a drill tip on there. Grab an actual drill. So you'll see it's kind of hard to see here. Sure. Do material here. Oh, gotcha. I see. Thank you. Yeah, that's much easier to see. Thank you, Justin. So now you'll see it's right to that spot that I had picked, because I had picked the point right there. So it makes it way more clear, way more easy. I'm super glad to see that they're adding this into more aspects of Mastercam. There's some feedback we've gotten from all of our classes. It made it so much easier to understand where things are actually going to get that nice graphical view. Show that off one more time here. And not only that, if you have something that isn't starting right on the face, that happens a lot. That is a huge point of confusion, because if you don't change that number, what does it do? It says you're embedded in the stock, right? And then you have to turn off the stock update, see what it's doing, and then, okay, now I can fix it. Now you just see, oh, I just need to pull this out a little bit, and I'm golden. Everything's fine. Any questions on the graphical planes that we've added in 2026? Pretty straightforward, right? In addition to that, in lathe, we've also added the ability to save different configurations of your toolpaths. So just like in mill, how you have your drop down now, where you can save a bunch of different settings for different operations, you have that in lathe. And if for those of you that aren't aware, I believe they added this in, was it 2025 or 24? But they added that. I think it was 25. So if I get my settings the way I want, I can actually just come up here and hit the save button, which was never available in lathe before. But not only that, I can save it to the default, but I can also save a custom one. So I can come in here to custom. Then I can hit the plus sign down here. And I can say Kyle's aluminum rough drilling or something like that. And that's going to save that back. And then I can reference that later. So now I have a drop down. I can go back to my defaults. I can add as many of these to each tool operation as I want. So if I have a lot of different scenarios, like I want a certain way of pecking, speeds and feeds, things like that, it will grab all that in here and place it for you. I think the only things it doesn't grab are the tool and the geometry. So you'll have to put those in each time. Awesome. All right. So that's all I had for the new stuff in 2026. I'm going to go through a few tips and tricks, and then we'll do a little bit of a Q&A, or we might go to lunch depending on the timing. But yeah, let's do a few tips and tricks. So the first thing I want to go over, has anybody not heard of X Plus? Not heard of X Plus? Okay. X Plus is mostly known for great setup sheets. We all know the Mastercam sheets. They're good, but they're kind of hard to work with. It's hard unless you know how to get into the designer and add and subtract things and find the root hierarchy and adding all that in. It can be very time consuming. X Plus makes it a lot easier. You can literally just add and subtract things in a dialog box just like making a toolpath. I'm going to show you a few things with that. But what it's lesser known for is fixturing. How many people wish they had a better organization for the fixturing, where you can just pull it in and maybe auto clamp on your stock? Let's take a look at some of that. So I'm going to grab just a step file.
Why he does a question. How many of you guys do not use X Plus right now? Cool. Okay.
So about half the room.
That's half the room. Okay.
So I'm going to pull in X Plus, or I'm going to pull in just a step file here. Just have a little standard little part, probably 2 operations. Could either do it on the lathe or the mill. We're going to assume we're doing it on the mill. And I'm going to set this job up like I normally would. So I've just pulled in a step file. I'm going to say machine, pick my post, and I'm going to set up my stock. Rectangular, grab this. I'm going to give a little bit of extra stock on the sides because anybody get their stuff already squared up for them? I know I don't. Grab that, we'll grab this. And then I'll add a little bit to the top and then a little bit to hold on to in the bottom. Perfect. I'll turn on my stock display so you can kind of see the extra there. And then I'm going to go to my X Plus tab, which gets included when you download the software. And I'm going to go to my add fixtures. One of the coolest things about this is you can add as many fixtures as you want. So this is just a list that I came up with all the stuff that I like to see in there. So I have my standard 5-axis vices, I have my Haas vices, I have my Kurt vices, I have a few 3-jaw chuck for a lathe on here as well. So you can see I can just go through the list here and kind of just pick what I want, right? So once I kind of figure out what I want to use to hold on to this, say I'm going to put this on the 5-axis first. I'm going to grab this 5-axis vice right here. I'll zoom in on this dialog box a little bit. And I'm just going to hit the green check. So it brings in the model, centers it up, no matter where it's at, and clamps onto it, all automatically. How much time would that save you from messing around with, transform, dynamic? Oh, and you know what? Maybe I did the wrong one. I actually want to run this on my 3-axis. Let's just back up here. I just hit Control Z for undo. I'm just going to come back in here. I'll grab this really handsome looking QTE vice here. Shameless logos there. Put that on there. And you can see for this one, I set it up to where it's going to go on that little cutout. You have control of where it automatically comes in. And not only that, you can actually set it up to where it goes on the floor, and you can put in the parallel size if you want to use parallels. So for this one, I put it on the cutout because it's just a little cutout there and I want it to be on the top. Well, let's use a different configuration where we can add in those parallel sizes. So I'll just hit undo one more time. And let's grab one of these Kurt vices. Yeah, this one right here. So the way we control that is it's called span depth right here. So say I wanted to use a 1-inch parallel under this part. I'm going to just put 1 inch right here. Not 10, 1. There you go. And you'll see after a second, it puts it right where it needs to be. So it's 1 inch above the bottom here is the way this one's set up. So very quick, very easy. I've even done a configuration where I didn't want operators to think about that. So I just put all the parallel sizes in there and they just pick it and I lock the span depth completely. And that way you have a model of your parallels and it just makes your list longer. It's however you want to do it. This is all very customizable.
And I will add, because Kyle's the one that figured this out, it could be fixtures too. Subplates with dowel pins. All of it. It's not just set devices. It'll always put it in the location that you have set in that fixture.
And not only that, it's not only good for vertical, you can use horizontals as well. I have one in here that is for a horizontal. The only difference you have to do is you have to set up your stock the same way you'd set up your toolpath. When we program horizontal, what we do top plane and then front plane for B0, right? So when I set up my stock, I just have to put in that front plane. If you guys didn't know, there's an option here to change the plane for your stock. So you just have to change that when you're on horizontal. So if I wanted to bring that in, I'll just go back to my fixture. I think I have one in here. Yeah, I have a little tower vise in here. Now it's only going to do one station. You might have to transform the part after that, but it is still a nice time saver. So I'll go ahead and hit the green check. We'll see what it does. After a second, there it is, nice and clamped. So moving on from that, what it's more known for and what more people seem to ask us about is the setup sheet side. How many people use setup sheets? About two-thirds of the room. Anybody not using setup sheets but are interested? Let's take a look at what this has. So I'm going to open up the same part just with a few tool paths on it. All right, so we used X plus to grab it, and now we've programmed it on top side on the 5-axis, and then top side on the 3-axis and back side on the 5-axis. So now that I have all this ready, I want to get all the information out to the shop. How do we do that? We just walk over and tell them what's going on. Sometimes I don't even remember if I programmed it, so I really like having a tool like this. This is a setup sheet that QTE developed. This is one that kind of incorporates a lot of things that I like to see on here, but it's very customizable. So if you want to see something different, shoot us an email, let us know. But as you can see in the dialog box, we can change all sorts of things. And a lot of these things pull directly from Mastercam, so you don't have to type it in each time. So like the date, when was this posted? What's the name of the file? What post processor are we using? What kind of material is it? If you set the material up in the stock? You can actually pull the programmer name too. I can either set this up as programmer or I can set it up as username. See how it puts my name right in there automatically? That's how my computer's logged in. So it's a nice way to track it that way too. Not only that, I can put my comments in here. So I have my comment for setup 1, I have my comment for setup 2, and this is just the tip of the iceberg. This is just in the header. This is all customizable for you. You can subtract, you can add. And then what I'm going to do now is I'm going to go to my parameters. Parameters are the things that are in the toolpath, things that you need to know how much stock we leave in, is the coolant on? If you're on a mill turn, which head are we using? What axis combination are we in? Are we using the upper turret? Are we using the lower turret? Are we on the right spindle, left spindle? Things like that. So I'll go to my parameters, and you can see, I believe there's around just under 50 parameters you can add and subtract all on your own. Works just like you want to grab something over here, you just hit the plus sign right there. And then you can move the order of what you want to see all on the fly right here. Let me tell you how much easier this is than trying to add it in the Mastercam's native one. Even though the Mastercam native one is great, it's just not as easy to move everything out from a user's perspective. So now that I have that, I'm going to go ahead and hit the green check. And let me do one more thing. Let me grab all the toolpaths in my first operation. I'm going to orientate my picture the way I want my operators to see it. So I have a nice ISO view with the stock and the holder and the part and everything. And we'll go ahead and hit that green check and see what it looks like. So now you can see, I can see my part. I have all my header information. I have all my notes up here. I have tool cards that show me shaded versions of the tool with all the information that I want on there. Holder name, manufacturer, some of the things I haven't filled in, so that's on me. How much, what's the lowest minimum Z it's going to do, cycle time for each tool. And not only that, in this one that we've made at QTE, we've split these up into the different groups. So especially on like a lathe, I always split up main, sub, POCO. It's awesome for that. Or if I'm doing roughing, finishing, hole making, and deburring, puts all those groups, and then it adds a little time for each section of what it's going to do all together. And like I said, all these categories, you can add, subtract, whatever you want in there, and you can move around the order. Let's do a few other, because there's a ton of samples that you get, for free after you purchase this. So we'll just grab, let's do default 4. Let's see, default 4. So same deal, just a completely different look. We can add your logo in there nice and easy. One thing I really like about this one, if we turn on the bitmap, which is just a picture, so I'll go back into my settings over here, and let me find the bitmap. Like I said, there's a lot of settings over here. It might take me a second to find it here. Oh, it's already on there. Okay. Let's see. Ah, there it is. So when I go down here, one really nice thing I like about this is I'm going to take the operation list and just minimize it. And I can hover over this as an operator. I can see a nice blown up picture. I can see my stick out. So if you didn't want the tool cards in the beginning, you could just have it in a condensed tool list like this and then hover over for a bigger image. It's very, very, very customizable. You can put it in Excel, a little bit more difficult, but you can do it. The HTML is nice. You can just print it as a PDF and then share it out in the shop. But it's very versatile. Any questions on X Plus before we move on to something else? Awesome. Sir.
When you go in to save, I've noticed if I leave all my preferences blank, save a copy of it as your custom template. And then that will always pull up when you go.
Exactly right. If you go through and you change everything the way you want it to look, you can just hit the save button. And you can either put your company name or you can say my default one. Each programmer could have their own different default. I wouldn't recommend that. You probably want to get on the same page, but yeah, you can absolutely save and make your own. It's not locked out whatsoever. So you can start with one of these templates and then put the information that's important to you and your shop and save it out. It's very easy. I'll show that really quick. Thank you. Great question. So if I come in here and I go into, let's go on this default again. And let's say I wanted to put the bitmap, or let's say I want to add something else. Let's add something. I'm going to add how many flutes are in the tool. Tool flutes. Add that in. And I'll hit save. I'll just call this QTE test. And now it will always come in that way whenever I load that. And it does remember as well. So if I go down, you'll see that it should have all those flutes in there. Yeah, right here. So put that in right there. Nice and easy. Something else that's important for when we're trying to share our information with the shop. Everybody here use Verify, just native Mastercam Verify, just to check stuff out. Anybody wish they had that for their operators to grab without having to tie up a seat of Mastercam? So if you guys didn't know, you can actually save out Verify as a presentation. So, and it runs without a seat of software. So you can just save it as a presentation. They can see what motion you're after. They can use the compare feature if you set it up for them, so they can see where the stock's left at any given point in the feature. So if I were to save this out as a presentation, I could put it on Justin's computer or somebody's computer that doesn't even have Mastercam on it, and they could run this. So it's great for the shop guys. No, this is just through Mastercam, just Verify. So if I take this same project here, I'm just going to go to normal Verify. And apparently this has been around for years. I've just learned about it this last year, but it's a great tool. Oh, and another thing I'll show you guys is, anybody ever use bookmarks in Verify? Bookmarks are amazing. How many times have you got annoyed that you have to restart the whole thing to get the stock all back on there? You can actually save bookmarks at the beginning of each operation. So if you come up here to Home, Automatic Bookmarks, and change it to Operation right here, you'll actually save a bookmark, and I'll just run this really fast. You'll see it's saving me a bookmark. It's freezing for a second and saving a snapshot of where that's at with stock. So I can just go back and look at it, go back, look at it, go back, look at it. We'll wait till that gets a little bit further, then we'll take a look. So let's say I want to go not to all the way to the beginning, but maybe operation 3. Normally what would we do? We'd hit go back because I want to see the stock get removed. Now I can actually just click on one of these blue bookmarks, and it takes me back to that stock condition. Nice and easy. That was a lifesaver. I love that one. But what we were talking about before is saving this out as a presentation. So right over here, You can save it in any position on here you want. They can always reset it. The operator can put it back to whatever spot. But if you wanted to signify something like, hey, look at this, you can save it in a certain spot. So I'll go ahead and save it at this spot, and I'll say save presentation up top. I'll just save this in my downloads. Awesome. I'll close this out. Oh, it's still saving. I want to wait. Close this out. And now you can send this, put this in the job folder so that your operators, if they have a question for you, they don't have to run all the way back to programming office, or if he's gone that day, they can actually just open it up without having a seat of Mastercam. So I'm going to go to my downloads, and this all runs self-contained. I'm going to just double click on this. It'll be the name of your project. And look at that. Now I have a copy that I can run through. And that's all standalone. Don't need a license for that. So if you wanted to ship that out and whatever computer, as long as they have a decent video card that can handle verify, they'll be able to see what's going on. Any questions on saving a presentation? It's pretty self-explanatory. You hit save and it shows the shop guys what's going on. I'm going to do a little bit on access control next in Unified. Me and Justin both preach the gospel of Unified on the daily basis. So we're going to go over a little bit. It's going to more so be theory, kind of the way I like to think about how to approach access control. One of the main things that I know I was guilty of when I first started doing 5-axis toolpaths is I wanted to make it look as badass as possible. I wanted that machine to be whipping around. I wanted it to look impressive. But what I've noticed with doing things like that on certain machines, some machines are better than others, is the more motion you have, the worse the final product is. So if you can eliminate axes, I know sometimes we need full 5, right? We need full 5 sometimes to get in spots. But if you can eliminate things from moving, you get a much better result. So that's what I like. That's what I like to do, and that's what I like to show you guys. So I'm going to open up a little bit of a part here. I just got some little parts here. Let's have some twists. We're going to make this stuff from scratch here. We'll look at this part first. So nothing too crazy about this part right here. There is quite a bit of motion that would happen if we left it on the normal surface. And you'll notice if we do our old standard surface with tilt, we're going to be in some heartache as well. So let's just take a look at what this is going to take to do. Now we can do this either way. We can go long ways, we can go across. It doesn't really matter. I'm going to go long ways for this one. On the Unified. And just like Justin was saying, is it cutting how I want, where I want, what I want? Is it the machine moving how I want? Is it avoiding what I want? Or is it coming in and out of the part the way I want? We really want to think about that. So firstly, let's go to our cut parameters page and let's tell it what we want to cut. So I want to cut this inside right here. And I'll probably grab a few of these down here as well. So it's cutting what I want. Now I need to decide how I want it to cut. I'm going to have it cut long ways around the helix. So I'm going to do a guide just to be contrary to Justin, who likes to use parallel. I'm just going to use guide. And we're going to set it up just like a traditional morph would work here. So I'm going to go ahead and pick my first edge. I'll do a single edge. Pick that first point. Then I'll pick my second edge in yellow here. Awesome. And also remember, I like to say my default this way. I don't think I've quite done it yet for 26, but I turn my collision off and I turn my axis control to surface. And oftentimes, even if I'm going to use a different tool, I start with a ball nose. That tells me if the motion is correct. I can't tell you how many times I've had collision on and I've had everything else right, but I've just stared at the wall for like 2 hours trying to figure out why I won't do what I want. So with those things, it really eliminates a lot of time. So I'm gonna go to my collision, I'm gonna turn it off. I'm gonna go to my tool axis control, and I'm just gonna turn it to plain old surface. I'm gonna hit the apply button. So you see we got a nice, clean looking motion. That's what I'm after. Now, when we go to play this, you'll probably see that it's not gonna quite work, but we're gonna play this really quick. I'm gonna use another little add-on called SECO Verify just to show the machine motion really quick, because backplot's cool, but it doesn't show you the kinematics that well. So you see it starts off pretty strong. Let's take a look in SECO Verify. Let's set it up really quick. Grab that. Move it up 5 inches, looks great. Sweet. So you see it's not too bad at the start here. I mean, there's little crashes, but we can fix that with what Justin shows in collision. What I'm more worried about is the axis control. I tend to use my collision tab as a last-ditch effort. I like to get rid of everything with axis control if I can. I like to eliminate as much as possible. So let's just fast forward a little bit to the end here. Bam! That's not great. There's no amount of surface with tilt that's going to fix that, is there? So the first thing we're going to do is just look at a few different options we have, because yeah, we're done. It's not even going to try that, hopefully. So we'll close that out, and let's take a look at some different options here. Now I know what I'm drawn to a lot, and I know a lot of others in this room are drawn to a lot, is just putting on surface with tilt and then trying something like, you know, maybe I'll do like 70 degrees. And I think we'll see, just like the other example, it's going to look great in some areas and then crappy in others. So once again, our motion looks great, and I might need to flip that the other way. I'm not sure if it's going backwards here. So once again, starting off strong. Ooh. Once again, not a great option. So what I really like to do, and I do this all the time with 5-axis machines, is I turn it to a 4th-axis operation. Because in a 4th-axis operation, you can actually control where your C-axis or your B or A axis are as that 5th axis. So whatever you're spinning around, so in this case, if we're spinning around the C, we can lock our B over to a certain location. I do it all the time. Eliminate as much motion as you can. And not only that, it'll make your part way more concentric. You're just spinning around the C and kind of dancing up in X and Z there. So let's go ahead and do that. So I'm going to turn this to a 4th-axis operation. And I'm just going to zero this out. And I'm going to lock this angle 90 plus, we'll do like 30 degrees, so 90 plus 30, 120 there, and I'll say around the Z. Let's see what we get there. So a little bit of lift up. We might need to change our angle a little bit, but let's just see where we're at. That's kind of cool. So we might need to change our angle a little bit. I'll turn on rotary axis so we can see what's going on before we go to verify. You can see how it's spinning around right now. So I actually want to get it tilted over maybe a little bit more, right? So I can access the side there. Let's tilt it over a bit more. And like Justin was saying, just change one thing at a time. One thing at a time will give you much success here. So I actually need to go the other way. So I went the wrong way there. So I'll just go ahead and change this out. Let's say 60 degrees. Let's see what that looks like. It's not too bad. Do 0 here. There we go. Now we're cooking with gas. Go ahead and backplot that, then we'll take a look. So now I've completely taken out all that extra motion, and no matter where I'm at, it's going to be good. Now I'm not whipping around trying to go upside down in this helix. I'm just kind of floating inside of there. So let's go ahead and look on verify at what that looks like on the machine. Nice and easy. We don't have to stop there either. We can do so many other things with this. So let's say that we didn't want to lock it to a fourth axis. We want to do like fifth axis. We could switch this to fixed to an angle, and I could actually make it change as it goes through. So maybe I could start at 60, then I work my way closer to 90 when I'm closer to the table, or vice versa. So I could say, I'm going to come in here at 0, or maybe we'll start at like 60 and I'll go to 90. This will work better in a configuration where we're going back and forth, by the way. We're going long ways right now, so we'll just take a look here. Back plot. So you see how it's kind of at 60, and then when I go to the end, it's more straight at 90. Let's take a look on the machine. Excuse me. Might need to hit it again. There you are. You see how it's moving just slightly as it's going through. So I'm using these things in tandem. I'm switching between fourth axis, 5-axis motion. Am I starting at this place? Am I starting at another place? There's so many different ways you can control this. And this is before we ever get to the powerful stuff that Justin showed us in collision. Think about those in tandem, what they could do. I might be hitting a few little red marks in here. Collision's going to take that right out. The thing I really like to impart is when you use collision to tilt to avoid, it puts a lot of motion in your machine. So I really like to take all of that motion out as much as I can and just use it very, very sparingly on that side. So we have another one here, and I'll wrap up this pretty quickly. I have another little part in here. We'll make another unified path for her. Just reopen this really quick. I will make this one from scratch too. So we have another little twist part in here, which would be kind of a hard one for surface with tilt to fix again, right? Because as that twist is going through, it's going to violate in some areas, look great in others. So one that draws my attention right away is, what if we tried just a point in the middle? What if I'm always going to a point? So let's give that a shot. So I'm going to do my steps again. I'm going to go to unified. I'm going to pick my tool. And then I'm going to decide what I want to cut, how I want to cut it. So what I want to cut is all these walls here. And then I'm going to pick how I want to cut it. I'm going to do another guide just to piss Justin off. Go all the way around to the end there. Kind of set it up just like a morph there. Make sure my collision control's off. And I'm going to set my axis control to the surface. Even though I definitely know that's going to crash. I just want to make sure my motion looks right. So before I continue, I'm going to fix this. I don't want to do a zigzag. I'm going to do a one-way. And I'm going to copy a little bit of Justin's magic here in the linking. We're going to do a horizontal tangential arc. We'll do like 25%. I'm going to copy that over. And then I'm also going to do a blend spline. And I'm going to use lead in, lead out. And now I have a nice little helical down there. So it's not much of a transition there. You could also do a spiral. I just find there's sometimes extra lift ups. So we'll use this one for now. So that looks great. Now, if we were to actually run this, you'll see the problem right away. My computer's thinking here. It's running too many things. It's hung up on something. There it goes. It was thinking. Sometimes as programmers, we're a little impatient with our software, aren't we? Never. And sometimes there's a little, I call them love letters in the background for Mastercam that you got to read before they'll let you continue. We got one of those, so I'll just hit OK on that. All right, let's backplot this. Perfect. So you'll see when I run this, it's going to crash all over the place, right? See how we need some access control desperately. So if we go in and do our normal thing, where this is usually the place I start, honestly, I'll come into my access control, and I'll go surface with tilt, and maybe I'll do something like 80 degrees, okay? Got that in there. Let it think for a little bit. I'll probably open up the step over on the next one to make it calculate a little bit faster. There we go. Oh, other 80 degrees. Good time to change that step over anyway. That's one thing I've noticed with Morph and Guide. They're opposite on which way you flip them. So sometimes you have to play with it a little bit there. So I'll open up that step down to 100. Perfect. So let's take a look at what this looks like. So it starts off really strong, honestly. I mean, there's a lot of extra wiggle in the corners that I wouldn't necessarily want, but it's doing what I want it to do until we get closer to the bottom in some areas and we're crashing all the time, right? So my second thought on this after, surface with tilt is maybe I point it to a point in the middle of this pocket. So let's do that. And this is where I can show the trick that Justin taught me again, where I can use that reference point. So I'll come in here. I'll go to my axis control. I'm going to say from point. And you'll notice I don't have a point right now, but I'm just going to go ahead and click on this. I'm going to use my temporary points by hovering, and then I'm going to shift click on that red dot. I'm going to pull that up, let's say 2.5 inches. And that puts me a point right there. So I don't have to get out of the toolpath to go into wireframe to create it, then go back in and waste all that time. And let's just take a look at what that looks like. Give it a second to calculate. Perfect. Let's take a look now. That's looking way better. But for me, honestly, that's once again, for this shape, too much motion. Once again, I would take this shape and lock it down to 4th axis and just have it spin the C around and jump up and down. Now, if I wanted to leave it at full 5, I would absolutely do that. But I might limit it in that case. Maybe I only want to do a 20 degree swing on that. I don't want to let it go buck wild in those corners like it was doing. So let's just take a look in our verify, and then we'll move on to something else here. Oh, let me switch out my part. It's the wrong part there. So one thing I love about the verify, SECO verify, is it's very quick to load, especially 5-axis stuff. So that's not terrible. I would run that. But I do think we could make it better by doing the same tricks that we showed on the first part. Any questions on any of the axis control that we looked at, or anything from Justin's seminar? Cool. I just have one more thing to show you. A lot of people have been asking us about Cam Assist, AI programming. Okay, yeah, that sounds like a good plan. Okay, perfect. If you guys, for those of you on the remote didn't hear, we're gonna go ahead and run that after lunch. We're gonna let Christian from SECO take the floor. Thank you for your time. No worries.
And what we'll do, he's going to do a quick little thing with SECO, and we're going to break for lunch. You can just bring your food, but we got boxes and stuff out there. And then, like Kyle said, he's going to do a cam assist. Everybody asked about that, so he's going to show you. He's got a part he can actually show you, and then we'll do some Q&A stuff. So kind of hang around. Well, I know it's a lot of sitting right now, so just bear with us.
All right. Is that working? Everybody hear me okay? Perfect. All right. So I'm going to switch gears a little bit. We were talking super technical on the programming side. I'm going to pull it back a little bit and get into just the overall view in what we deal with on a daily basis, what you guys deal with on a daily basis in your manufacturing environment. Talking about end-to-end solutions and partnerships across the entire manufacturing space. Don't think we talked about safety, but we've been in here long enough. Out the doors to the left. I'm going to follow you guys. So a little bit about SECO for you guys that don't know us. Looking at the center box there in the middle, we are part of the Sandvik group. A lot of people think Sandvik, they think Sandvik Coromant, the machine, the tooling company. You can see there under the machining division, we have SECO, Coromant, Walter, Dormer Promet, and Wolfram. And Wolfram's an interesting company. They are a powder manufacturer, and they actually do a lot of the recycling of any carbide material out there. They are a big recycling provider for us to keep the circularity going and not use as many raw materials as best we can. If you look on the left-hand side, as of the end of 2023, SECO is about $1 billion globally in sales and about 4,000 people. Now 4,000 people, that's, you know, a small area in the of the 40,000 in the Sandvik group, but we really pride ourselves on being a engineering solutions provider, not only tooling. And to kind of back that up, in 2022, we acquired a company called PMT. You'll see that on the right-hand side. And PMT stands for Premier Machine Tools. They're a small company out of Ireland, only 19 people, but they prided themselves on working with all aspects of manufacturing to bring solutions to our end customers. They are primarily in the medical component industry, but through their acquisition into SECO, we're taking that model and expanding it across all segments to aerospace, automotive, power generation, really anywhere that the customer sees value. And that brings me here, starting August 1st, actually, I'm transitioning into this role, regional manager for the Premier Machine Tool model in the Americas. So where it all starts, SECO has what's called an innovation hub. We have 2 of those physical sites today in the UK and in Germany. And we're in the works of having a physical space in the US in the Charlotte, North Carolina area. And then we have what we call virtual innovation hubs across the global footprint, where we have engineering teams in all the key markets, US, Mexico, India, China, all across the board, where we actually take customers' projects and we bring them into this space where, you know, we have the partnerships with machine tool builders, CAM programmers, fixture companies, verification companies, and we really use that space as a place to take your components and we have time to play and be creative with finding the best solution, whether it's a completely new component that maybe you're quoting, or a process that you've been running for many, many years, and your customer is telling you, hey, look, I need to up my productivity by 25%, or look, you know, we got to cut costs, you know, or we're going to have to go another way. Those projects are something that we want to take and bring to our innovation centers to prove, is there a better way? And not saying that it's we know how to do it better than you guys because we're not living it every day, but we have the time and space to make mistakes, to say, you know, let's look at a couple options and then discuss it together to figure out how would be the best way to propose it. And something that's neat about this innovation hub mentality is we'll give you a virtual solution and we talk about it from a virtual perspective. And then step 2 could be you send us your component or a scrap piece of material for that component to our physical innovation hubs. And we actually put it on the machines and run it. And we can show video, we can do verification and measurements and provide that data back as kind of a solution to do before it gets in your factory and takes up the time that you normally need to produce the parts that you're selling for revenue. You know, we talk about the jigsaw puzzle. You know, it's not one company that is going to be successful in doing this. It's a team approach, and so we really try to take that to heart. And us being a cutting tool manufacturer, we make drills, we make end mills, we make lathe tools. We're not the best in all of it, and ISCAR is not the best of everything, and Coromont's not the best in everything. Everybody has kind of their niche. And I think you guys probably have found that, you know, you go to certain manufacturers for certain niche areas of manufacturing. And we really find that not only in the tooling world, but in the entire manufacturing space. So it's really comes down to your specific application. And then we pick and choose what is the best solution to really optimize things. So this kind of gives us a really broad overview of the manufacturing process. You know, we really bring it down into 6 different bubbles. And if you look at the company's names on the top, those are all companies that are within the Sandvik umbrella. So Sandvik Group, they have ownership across all of these spaces. And, you know, for the last couple years, you know, people in the SECO or the Sandvik Group we've heard about it. You know, we see articles and publications about, oh, cool, you know, Sandvik just acquired PDQ Work Holding, or, you know, they're working a lot with Mastercam now. They've acquired Mastercam, but we really haven't brought that into a team effort, you know, a partnership effort. And so from a SECO perspective anyways, we really want to try to lead that from the Sandvik Group and bring all these companies together to, you know, because we feel as a tooling provider, we're in your factories more than maybe these other areas. You know, you guys are using tooling every day. You have issues every day, and with that, I mean, we need to be there to support it. So if, you know, we come in on a Tuesday, like, if, you know, for you guys that don't know Lee Ward, Lee's our local support application engineer. You know, he's in your accounts every day or every couple weeks. He sees issues, and, you know, he can call the guys at QTE, or he can, you know, be like, look, they're having some serious fixture issues. You know, let me bring this to somebody else, because we're not the professionals in those different spaces, but we are more connected in the industry. Maybe we can bring that solution to you guys if you're struggling. And then the companies you see there on the bottom, they are partners that are external to the Sandvik Group. Our innovation centers. We do trade shows every year. We specialize in, you know, different segment ITI events, which we call innovation through inspiration. We do those every year, and we center them around certain market segments like aerospace and automotive. And during those events, we bring in specific partners to showcase their advancements in their different segments. So this is kind of to give you an idea of what's possible and how we can try to help bring these solutions to you guys. Just the next couple slides are hitting on the different spaces and where we've actually found the biggest need and focus. So if you look here in the aerospace industry, we do what's called method of manufacture. So our innovation centers will take a customer's part, whether it's a blisk, landing gear, or any kind of a structural fuselage component, and we'll say, you know what, if we, you know, had no limitations, we would do it in this way, and it'll be from op 10 to final op, and then we can go through and explain that in a way and see, okay, you know, now let's form it specifically to the customer's application. And we're doing that for the automotive industry as well. Gears, knuckles, blocks, heads. It really just depends on the customer's application, either from a turnkey application or on an existing process. And as I said earlier, with Premier Machine Tool acquisition, they are very, very strong in background with the medical industry. A lot of the orthopedic implants, very difficult materials, very stringent cleaning processes. And that's really where we find a niche where we can bring a lot of value to you guys in improving your processes. Looking at how that can actually be applied, I'll go into a little bit more of a simple application, and then get on more that's a little bit more full solution models. And actually, sorry guys, let me back up. I want to talk real quick on something. If you look at this slide here, so a lot of people ask questions. They say, this is great, Christian. Do we have to do all of this? Is this, I'm good in my shop floor solution. I don't need. I've already got vending. I already have my, I know my tool costs. I'm really struggling with verification. Can that just be something that you guys can help me with? All this stuff is a la carte. It's like an a la carte menu. If we typically come in and have a conversation at your facility, and you guys know where your challenges are. So you know what? Box number 1 and 3 and 4 are where we're really struggling today. We've got excellent resources in our quality department for verification. We don't need help there. And so that's really what we think is great about this offer, is it's completely a la carte to what you guys need. So looking at this application, we had a customer, and it's really funny. Justin, I didn't realize that you were going to talk about an MDT face grooving application. and this is what one of the case studies here. This customer was machining a ring in very, very gummy P1 steel, so really, really long chipping material. And you can see here it's a 10 millimeter wide groove, 30 millimeters deep. So quite a bit of a groove. A lot of issues with chip control problems causing failure. Recutting chips, breaking inserts, and of course, anytime you're face grooving, your holder's gone. And the customer here, they were programming it the way they've always been, always done. They're pet grooving to try to limit that chip control issues, and they have a CAM software, but like you guys went into, there's such a depth of knowledge in different CAM programs that you may not be familiar with a different strategy to be able to shorten your chips and make it just a more repeatable, consistent process. So by us coming in, we were able to work with the CAM software company to look into doing a dynamic turning application, and some of our unique chip breakers that we have for dynamic turning, because it's really an innovative way to machine nowadays with these light depth of cut, fast movements to really get that chip to break. And with this, you can see oh, cool. Yeah, my mouse shows up there. The situation that they had beforehand, just plunging in using the full width of that insert, it just gives you just a horribly long chip. So pecking it can help, but it's not going to fix it. So by coming in and doing a little bit more of a dynamic tool path, you're spreading the wear across the entire radius of that insert, and you're able to really increase your tool life, and the biggest part, help with that chip control. So that's one example of how we could work together on a different application. And then to look at something a little bit more deeply, this is an area with a medical customer where they were having challenges where they needed to increase their throughput, and they called us in and said, look, you guys are really good at medical. You got a lot of good tools. What can we do on the tooling side, and machining strategy to really reduce our cycle times? And for us, we said, what? We have really good experience in knee trays. Can we look at everything? Can we just kind of look at benchmarking your entire process? How many machines you have? What's your fixturing look like? What tool approach are you doing? And through our partnership with that innovation hub, working with fixture companies, we said, what? Maybe we can set this up in a tombstone operation where you've got 8 parts in op 10 and 8 parts in op 20, and then looking on the outside of the machine, your operators, not able to set the parts up. So the machine's sitting there waiting. So let's do a 2 tombstone path operation where we can have both ops loaded all at once. And then while the machine's going, our operator can be unloading and loading parts offline while the machine's still running. So we worked with one of our partners and said, this is what we need to do. They helped design the fixturing. And then we also looked at dynamic milling strategies and combined with our tooling specifically for medical. And we were able to do, which I found to be hard to believe. I'm an automotive backgrounded guy, but when I saw this change here from a current 47-minute total setup to 16 minutes, a 30-minute reduction, I was in disbelief. Because, in automotive world, 30 seconds is huge. Half a second, it's a big deal. But I know in other industries, they're not as mature in the optimization of the processing. So really working in this team approach, it's really, really powerful what you can get done utilizing professionals in all these aspects at the same time instead of separately. Yeah, for the guys online. So Matt brought up a good point that, SECO can be the main point of contact, or the one that has the relationship. Your tooling supplier is there on a regular basis. He can be the point person, or she can be the point person to work with those professionals in the other areas to get this thing over the finish line in the timeline. Sustainability. Sustainability is a term that a lot of big companies and OEMs are using nowadays for recycling, being greener, and that's great. That's really great. But, if you look at the entire process, there's sustainability when it comes to tool utilization, reconditioning, recycling. There's also, from a cleaning perspective, but there's also sustainability from your company's point of view. Being sustainable and continuing to have business. And so we feel that, especially for the audience I'm talking to today in the programming world, it's, being as efficient as possible to be able to open up machine time so that you get more business coming in the door. So that's something that, we want to try to make sure that you guys are, hitting your sustainability targets as well. And looking in the recycling thing, I figured while I was here, I could give you guys an update. SECO and many of your suppliers, they're buying back your carbide. So if you guys are involved in that, or if you have a department, it's probably at one of the highest rates it's been in a long time now. We're actually buying back carbide for $13.60 a pound right now. It's one of the highest rates it's ever been in my 10 years at SECO. So if you're not recycling your carbide, talk to me after, or get with Lee, and that's definitely something. It's an easy check to get back from to hopefully come back to your tooling budget to be able to get some updated tooling, or work on a new capital project. So other areas of the sustainability area is looking at CO2 as replacing coolant. That's a really innovative new area of machining that I'm not as familiar with. So I would love to, if you're interested in it, I can definitely bring some information to you. But in certain areas where coolant's not allowed, or it can contaminate the part, like in orthopedic implants, that's something where we're really looking to help innovate and work with some other suppliers out there that are really taking this to the next level. And then also in certain areas of cleaning or parts washers, that area of the industry I know is it's very niche, but it's an area that some customers have a great need for. I'm going to skip this one. I meant to hide this one, but we kind of hit on that already. And I basically just want to close with from a SECO perspective, from a Sandvik Group perspective, we're looking to try to make manufacturing easy, fast, and sustainable. So hitting on the challenges and the shortcomings within your organization where we can be of an assistance or help. And then lastly, I will give a quick ploy. If you guys, here's our contact information if you want to take a picture, and then I do have a QR code that kind of goes over, it's got a couple questions, just a Microsoft form about, you know, what the content you saw today, was it interesting? Is there any questions you may have? It would be really helpful to, if you could fill that out, just to give me some feedback, and yeah, if there's anything we can actually meet with you guys directly on, we'd be happy to have some conversations. But thanks for your time, everybody, and QT, thank you for letting me present today.
No, thanks, Christian. And I guess just to kind of wrap this up from the Sandvik point of view of why why we asked Christian and the SECO team to present today, is that you guys have all worked with QTE for a while. And I think, one of the things that comes out of this presentation from them today is that you don't call them just to ask them a very specific Mastercam question a lot of the times. You call them saying, I have a problem with my process or something's going on, and they come in and try to help you with the solution, whether that's directly just changing a parameter in Mastercam or something else. You guys have a problem, you feel comfortable calling these guys. I think a lot of times there's a perception in the tooling industry was that I only call my tooling guy when I need a new 1/2-inch end mill and I need somebody to come sell it to me. You can throw these guys problems the same way. And now with Sandvik, again, acquiring all these companies, people ask us, what's the point of that? Well, it's to combine these two sides of knowledge that we have. We are truly a solution provider company. We don't just want to sell you a single tool and walk out of there. So I guess my message is that take advantage of these guys. You take advantage of QTE, take advantage of these kind of guys too. If you have a problem in your shop, throw it out to your tooling guys. And there's a lot more resources behind that than you might realize. So, yep. Thanks, everybody.
Okay, so last thing I'm going to say is, if you've noticed, Jeff Kleinheider's not here today. We got graced without him. So I'm going to throw his little 2 cents out. I won't talk as long as him, but just so you know, we do sell Vericut now. TDM is another product, and then like Kyle's going to go over Cam Assist. So if you have any questions in regards to any of that, we don't really do the technical side of Vericut. We're just the reseller. If you do, reach out to Jeff Kleinhardt. If it's something you're interested, most people in this town are already running it. If you're running it, if not, whatever. But I just want to throw that out there. Reach out to Jeff Kleinhardt and the sales team. They'll help you out. But yeah, let's go ahead and break for lunch. We still, if you're interested, Kyle's going to do the demo on Cam Assist and then some Q&As, whatever you want. But if you walk right out here, it's to the right, correct, Erica? There's some Jimmy John's boxes. Grab you a sandwich. There's drinks over here. You can eat out there in the commons. You can come back in here. You can come talk to me. Do whatever you guys want.